Recording in progress.
Okay, it's 9 o'clock. Um, I think I'm gonna get going. We have quite a packed session today. Welcome to everyone. I just want to first check with you that you're in the right track. We have multiple tracks today. This session this morning is Foundations of Quantitative Research. So if that's what you're here for, you're in the right place. If you would like to join the other track, please go back to the links that we have sent you and log into the other meeting. We have a third track as well today, but that will only be open this afternoon. If you're in this session, I'm assuming that you might have some interest in the other practical sessions on quantitative research later today. So after the session at 1 o'clock, please do check your links if you're interested in some more detail on quantitative analysis and some practical example using Stata or SPSS. Please check the program and go to the module that will suit your needs later today. A bit more about me. So I'm Zakir Asmal. Some of you I've been communicating with um, this whole week, sending you the links, making sure you get into the meetings. So yeah, this is me. You finally get to see me and not just me bothering you in your emails. Today's session is about foundations of quantitative research. We're not going to be doing anything hectic. It's about thinking about data and about how we use data in our research. So we're not going to get into any heavy statistical analysis, but yeah. We hope you go away with a good foundation of quantitative research and that it will serve as a good foundation as you go into the other sessions later this afternoon. Um, just to introduce myself, I'm a research manager at the HSRC in the Equitable Education and Economies Division, an economist by training. Um, so yeah, hopefully I'll be able to answer some questions as well, but we have some more experienced and esteemed colleagues here to help us through the session this morning. Before we get into their bios, I just want to highlight a few things. We are being recorded, and this is also being live streamed at the moment. So just to be aware of that. Um, yeah, in terms of questions and answers in this session, I will be keeping an eye on the chats and be posing them to our presenters as we go through. So if there are enough questions, we might have a break in the presentation to take those questions. Otherwise, we'll do that before or after activities or at the end of the session. Um, Other than that from me, that's about it. But before we go on to our presentations, I'm just going to give you a brief bio of our presenters. So our first presenter, who will take us to 10:30 today, is Dr. Syed Parker. Dr. Syed Parker is a senior research specialist in the Center for Science and Society of the Equitable Education and Economies Research Unit of the HSRC. He obtained a B.Sci. majoring in psychology, anthropology, and gender studies from the University of Cape Town, and honors in clinical psychology, a master's in research psychology from the University of the Western Cape, and a PhD in science and technology studies from the University of Stellenbosch. He has 20 years of practical research experience in both the public and private sector. His research has allowed him to lead research teams in the development and measurement of science, technology, and innovation indicators, with recognized expertise in the public understanding of science and areas of science engagement. His work focuses on large-scale digital and online surveys, including more than a decade working on the National Research and Development Survey, and more recently, the South African Public Relationship with Science Survey. Dr. Parker has more than a decade of qualitative research experience and numerous publications to his credit. Then, when we come back from our break, we'll have Dr. Vandutsa Mbanda. Dr. Vandutsai is a senior research specialist in the HSRC's Equitable Education and Economics Division. She is an economist with close to 20 years of research experience on socio-economic aspects of social exclusion, economic development, job creation, unemployment, poverty, inequality, and food insecurity. She is skilled in quantitative as well as qualitative research. She holds a doctorate in economics from the University of Johannesburg and a master's in economics from the University of Pretoria. So I think you can agree that we have very experienced and very skilled experts to help us here today. So without any further input from me, let's get to our first presentation. Thank you.
Thank you, Zakir. Thank you for that. Thank you for that warm welcome, and to all of you online, welcome. 9 a.m. I see the chat is buzzing with lots of excitement, lots of activity. Let's maybe start the session. Tell us where you're from. Use the chat. Drop a comment. Tell us which country you're communicating from, where you're joining us from this morning. It'll be lovely to know who you are and where you're from, so that we know who you are and you know who we are. And as you do that, I will begin to prepare my presentation so that we can begin our conversation. But do drop a comment in the chat so that we can see who we are talking to. Thank you, Bronwyn. Lots of people from South Africa. I've got a screen to my left, so if you see my eyes going that way, that's the reason why. Fatu, welcome to you. Thank you for joining us this morning. 9 a.m. talking about quantitative research, guys. That's a big thing. It's a big thing. Welcome from Abu Dhabi, all the way on the other end of the world. Such a pleasure to have you here this morning. So as our colleagues drop us the locations in the chat, let us begin talking. Let us have a conversation. As we have our fingers on the keyboards, my colleagues, tell me, what is the first thing that comes to mind when all of you think about quantitative research? Drop it in the chat. Let's have a look to see what your thoughts are as we begin this almost 3-hour conversation this morning about quantitative statistics. Relationships, that's a good way to look at it. Statistics and numbers. Lots of people commenting numbers. What do you feel when you think about quantitative research? Let's dig a bit deeper. We've got variables and statistics, causation, analysis. Data analysis is something that's just come through. Excited, experiments. And we'll wait for one more before we continue. So a lot of the comments has been about problem solving, statistical analysis, numbers. Mathematics is something that often comes up when we talk about quantitative research. And so maybe as we begin the session on quantitative research at the 7th Annual Emerging African Researcher Training Academy, I should start with a confession. About 26 years ago, when I was completing high school, I near failed mathematics. It was a shock to me. It was a shock to everyone in my family. But I was never that good at numbers. Must be honest, it wasn't something that appealed to me. It was very abstract. It scared the hell out of me because maybe I didn't understand it, and quite possibly I didn't value what it was trying to do. But that being said, later on in my learning journey, I encountered the world of statistics, which in some ways gives meaning to numbers. It takes the numbers from abstract forms into a real world scenario and links them together. And hopefully by the end of the session this morning between myself and Vandutsai, you will walk this journey with us. We will begin to understand some of the foundational aspects of quantitative research and how it can be useful to you in your research journeys, whatever you may be doing at this time. So let's get started. The learning objectives in this session will center around a few key themes. And so by the end of the session, we would like each of you to be able to have the skills that will allow you to explain what quantitative research is, describe the purpose of statistics, to be able to differentiate between qualitative on the one hand and quantitative statistics, to understand the research process, because quantitative research is more than just the numbers. It's more than just the statistics that each of you will be able to do. It is understanding the full value chain, from research design, understanding research questions, developing problem statements, formalizing your research process through questionnaire design, data collection, data cleaning, data analysis, and reporting, and demystifying that process, because a lot of it is big words that sometimes we don't always understand. And here come some of them. You will be able to identify the differences between a population, samples, and what variables do for you in your research. And most importantly, you'll be able to recognize common forms of quantitative research, and at the end of the day, explain why statistics matter in research. So, what is it that quantitative statistics does for us? It allows us to use numbers to answer a research question. Put in a different way, it allows us to build evidence through data. Now, I know I started this by saying I wasn't very good at looking at the numbers, and the data started to make sense, because in reality, friends, all of us, we already use data in our everyday lives. All of us. We make basic inferences based on observation. We pattern match. We average our expenses and our incomes. Many of us over the last few weeks have engaged in some form of prediction as to who would win the World Cup. We weigh evidence as we see it around us in the world. And so what that does, it tells us that statistics is not necessarily mathematics. In many ways, it is the forensic evidence that separates real science from lucky guesses that we put out in the world. Now, I may give my age away when I talk about this, but it reminds me in some ways of a popular series that aired, I guess, about 20 years ago, but for the last 19 or so years, called CSI, and you'll see the little image in your screen on the bottom right-hand side. And CSI means crime scene investigation, and it was a series about how lab technicians use real-world evidence to piece together what happened at a crime scene. And there was a gentleman called Gil Grissom, who's the senior man on the bottom right-hand side of the image on your screen. And he had a beautiful saying, and that was, "I'm wrong all the time. It's how I get to right." And I think that's the key point that we must begin to hold in our minds when we think about what statistics does for us. We have a question. It allows us to test that question with real-world data and real-world evidence, and pull that evidence together to come to some kind of conclusion that speaks to our question. And so it's a process. And very often that process is repeatable, because we have to constantly test and retest our assumptions. We have to retest and retest the data. And at some point, we will find a pattern in which the data speaks to the evidence. It may validate your question and it may go against your question. But at some point, you would have done the work that interrogates the data in a way that speaks to your research question. So remember this, we are all forensic scientists using data to answer questions that give us the evidence in our daily lives. So why does statistics matter? It's the only way we really know how the world works and whether something is true or not. And so we can ask many, many different questions. In today's world, does social media affect mental health? And, we all have that friend that scrolls too much. We all have that friend who scrolls too much and sometimes has questionable behaviors. And, that's okay. We're not here to answer those questions or speak for that friend. We all have these questions in our lives. Things like, does more science engagement increase public trust? Does increased education lead to improved employment outcomes? A couple of years ago, during the COVID pandemic, a key question was, does vaccination reduce disease? And so, as thinking people, we look at some of these questions and we look at it and we say, yeah, we've all got that friend that uses social media too much, who's a bit loopy, you know? I've attended many science engagement opportunities, and I do trust science a lot more. I've got many years of education and I've got a very good job. So clearly there must be some link between education and employment. I've been vaccinated. I haven't caught serious diseases. And so maybe there must be a link. And that's good. Intuition is very good. But there's a danger. We must remember that our intuition makes for terrible scientists. So statistics and the use of statistics helps us to answer these questions more objectively. It allows us to take a step back and gives us the tools that in some ways protects us from our bias. And all of us, we have some kind of bias that we bring in to the research world. And so coming back to that analogy about CSI, let's think of raw data like eyewitnesses. Very unreliable. Eyewitness testimony is the worst thing that you can ever rely your closures on. It's always full of bias. It's always full of error. And so what we need to do is interrogate the raw data in some way, shape, or form that gives it less of an error, more meaning, and brings it closer to what we're trying to understand. And so there's different kinds of statistics that will do that for us. Think of descriptive statistics like a summary of all the interrogations. You spoke to all the eyewitnesses, and now you've got a long report that gives you a summary. That's your descriptive statistics. Things like averages or means, standard deviations. These things give you a big picture of what went on in this large research study. You then have inferential statistics. These statistics tell us whether what we've observed is an effect of random chance or if it's really due to some other factor within our data set. We've all heard of p-values, probabilities. This is where inferential statistics come to play. And then we also have another tool in our toolbox, which is confidence intervals. And these really, in a very broad way, tells us about the precision of our measurement, how accurately we've measured something. It speaks to things like error. It speaks to things like reliability. And so it really tells us a lot about how precise our measurements are. And that's really important when we're talking about statistics, because it's one thing to know. It's another thing to know with a degree of certainty. And we'll get through all of us. And so, my dear colleagues, if any of these words, descriptive statistics, inferential statistics, confidence intervals, research bias, error, if any of these words, and I know we're only doing this in English, and we've got people from across the continent in the session this morning, all 156 of you. If any of these words seem a bit alien, a bit foreign, we will get to them. We will understand. You will understand them. We will explain what they mean. We will go into detail what descriptive statistics are, what populations are, what samples are. So please don't be put off by some of the technical terminology. We will begin to explore and unpack some of this in a very foundational way this morning. And then my colleague Bandutsa will take you through some of the more detailed uses and use cases for some of these skills that we will do this morning. So for some of you, this may be a recap of your earlier learnings, but it's always good to come back to it and to begin to understand these concepts in a foundational way, because it gives you a new understanding. So let's use the chat again, right? Statistics appears in our everyday lives. On the left, we have a number of examples. And so tell me in the chat, how many of these are examples of statistics? Let's give it a minute for the chat to come alive. And while that happens, I'll have a sip of water. Fantastic. Thank you, colleagues. Indeed, All of these are examples of statistics, everyday numbers that we summarize, that we compare, that we question. So things like election polls really relies on statistics of sampling, descriptive statistics. Things like weather forecasts to know what it's going to look like today and tomorrow relies on probability modeling based on data that's collected. Medical research too often relies on inferential statistics, hypothesis testing to understand the impact and the effect of medications or certain interventions on medical tests that happen within that setting. University rankings gives us the use of percentiles and so on. Sports analytics, people that have just come out of the craziness of the football soccer World Cup will know that regression modeling tells us a little bit about based on what has happened to tell us what may happen about in terms of predictions, and then credit scores, which no one really likes, tells us a little bit about regression modeling, logistic regressions, and more frequently these days, machine learning and AI is used to understand how what we've done financially in the past can determine how we will behave in the future based on the data set that's available to our financial institutions. And so coming on to what quantitative research is, if we were to boil it down to a definition, essentially it is a systematic process of collecting and analyzing numerical data to identify patterns, test hypotheses, and establish some kind of relationship. And often these may be cause and effect relationship. The key factors here is that it is a systematic process. We go in order to ensure that we collect and analyze data in a way that is meaningful, number one, but also that ensures that the patterns that we identify and the hypotheses that we test are done so in a way that is accurate and answers the research question that we are seeking to explore. So primarily, it asks the questions like how much, how many, how often, and we use that information to generalize our findings often to a broader population. So the characteristics are that it's numerical, that it is structured, that it is and needs to be objective, that we can replicate it in different settings, that if people take our data set and apply the same statistical methodologies, they should come out to the same answers. And that gives us a tremendous amount of analytical power. And so what does this mean in a real world sense, right? It transforms abstract ideas into measurable numbers so that we can test our assumptions with a degree of precision. And so when we talk about things that we measure in the social and human sciences, or even in the physical sciences or health sciences, we often think about stress. It's not a physical thing. We can't find a stress. We can't identify where a stress would be found and go and physically count them. So we have to find a way to make it more measurable, and therefore we use different types of scales. And then we convert those into numbers, and those numbers would then lend themselves a lot better to quantitative analysis. And we'll talk about those a little bit later as we go through this morning's program. And so we all at some very, very high level have this understanding that you have quantitative research on the one side and qualitative research on the one side. For many people, qualitative research is a little bit more friendlier than quantitative research. There's a bit of, people are daunted when it comes to working with quantitative data. But I think when you look at it, each has its own strengths and limitations, and each is able to answer different types of real world questions. And so when we think about qualitative research, it helps us to understand, explore the world, to generate new ideas or theories. While quantitative research overwhelmingly helps us to describe, to compare, to explain, to test hypotheses, and to test the impact or the influence of different things on a data set. They use different types of data. Qualitative more often uses things like words and text, more recently images, audio and video, observational data, and it relies on that to draw conclusions about particular samples that have been used. Quantitative research, on the other hand, uses numbers and counts and measurements and scales and percentages, and it draws inferences from those observations, and it's more able to apply those to broader settings. Sample sizes usually differ. Qualitative usually uses smaller, not necessarily small, but smaller sample sizes, while quantitative research is able to measure larger sample sizes, sometimes in the thousands, tens of thousands, when it comes to population statistics, even in the millions. And so the power in terms of analyzing large volumes of data is often with quantitative data analysis. We'll often then think of the strengths and the weaknesses. Qualitative data allows us to take rich, deep, in-depth, contextual, reflexive, flexible views of our research. It allows us to spend a lot of time with the little people and try and get the bigger picture for what's going on. Quantitative data, on the other hand, is generalizable. So we can use a very small sample of the population. We can be objective. We can apply statistical tests to it. We can look for things like causality. And in some instances, we are able to also generalize back to a bigger population and make statements about a bigger population. And so each of these have a strength, but at the same time, they also have some areas which some people might consider weaknesses or things that they are not particularly good at. On the one hand, qualitative research tends to be subjective, hard to generalize, time intensive to do qualitative analysis. And there's lots of software that's come online over the last few years that makes it a little bit easier, but there's no way of escaping the hard work that goes into doing interviews, reviewing qualitative data, and the time spent in going over it and trying to understand what's happening in the context of qualitative research. Similarly, quantitative research, while it lacks the contextual depth and structure, it does have its own positive points, but it's also because it looks at things in a particular way, it may miss unexpected findings. It is only able to look at things in a way in which the researchers have set them up. And sometimes if things are unexpected, it throws things a little bit out of whack. And so sometimes you have to be quite critical as well in analyzing your quantitative data. Then someone in the chat actually alerted me to the fact that there's the blending of these two, so a mixed methods approach, and these have become quite common over the last few years as well. But essentially, they are based on qualitative research on one side and quantitative research, and they each have their strengths and weaknesses, and sometimes capitalizing on the strengths of each one while minimizing the weaknesses of each one leads us to adopt a mixed methods approach, and that was Carnita quite rightfully said that there is a place for mixed methodologies as well. So when we think about quantitative research, we often think about data. We think about what data sets may look like. And in general, we have 4 different types of data or data sets. You have survey data, which many of us would be familiar with. This is often where people go out into the field. More common these days is things like online data gathering using cell phones or online techniques. And they ask people questions. So we go directly to people, we use questionnaires, and we ask people questions at, for instance, on the screen, university students about study habits. We ask people in households about income and expenditure, public opinions about things like sport, or recently in this country, we've had challenges, social and political challenges. And so we ask people what they think about different things, and we apply different methodologies to survey data than we would to any other type of data set. The next type of data set would be experimental data sets, and these often have different groups, and a treatment group and a control group. At times you have more than one type of treatment group and different control groups. And so here we have data that's collected by researchers in which they manipulate some variables and control for other variables in order to test cause and effect. Very often this is used in the medical setting where we're trying to understand the effects of new medications. Sometimes in social sciences, we use this when we're applying new methodologies and we're trying to understand how different teaching methods, for instance, have an outcome or an impact on test scores. In the industrial world, sometimes this is used to understand the effects. For instance, on screen, we see the example of how fertilizers affect plants. And in that case, they would control for different things like humidity and moisture and sun and heat and so on. And so experiments control for certain things. They have a treatment group and a control group. And these use things like t-tests, ANOVAs, confidence intervals to try and understand what the outcomes specifically mean in terms of the effect that they're trying to understand more closely. And then you have secondary data sets. And this is data that's already been collected and someone else then uses it for a different purpose than what it was intended for in the original research. And here things like population census data, data from your statistics body within your country, like StatsSA in South Africa. I worked for many, many years on the National R&D Survey, and often we'd get researchers approaching us to use our data for secondary analysis, where they're trying to understand the impact of gender on innovation activities, the impact on location, be it a rural or urban location, and how that influences the propensity for people to innovate in the South African setting. And so often it's descriptive data. We use trend analysis, time series data, where we can look at how things change in terms of whether it's gender, whether it's innovation propensity, from one year to another year or over a period of time from 2005 to 2015. What does the 10-year data series look like? Now, that data was collected to measure R&D or innovation capacity, not necessarily to understand gender dynamics or geospatial dynamics, but secondary analysis of data sets allows us to do that. So that's the third type of data set. And then the next type is administrative data. So this is data that's generally routinely collected by organizations, but then used for additional purposes that was not its original intention. So here are things like school records, hospital records, trying to use hospital admission records to try and understand the time of day when patients are admitted, the type of trauma experienced. Is this related to maybe things like, are there more trauma patients on a weekend, on a Friday night to Sunday night? Do more road accidents occur when we are closer to payday than when we are further away from payday? Is that related to alcohol consumption? In the school setting, we look at attendance and performance. Is it that learners who attend after school classes have better academic performance? Is it that those who attend or arrive at school late maybe have poorer performance at the academic results, and so on? So it's the use of routine data collection for research purposes. And this is very, very useful because it allows the researchers to access records and to access data and apply it to a setting that it wasn't originally intended for. So there are different techniques, there are different ways in which we can apply statistical methodologies to different types of data, but they all help us to answer real-world questions and to make decisions based on evidence that we see within the real-world setting. And so when we think about data, there's different kinds of data. And the type of data you collect really determines what type of statistical tests you can use. And so we'll explore this in terms of what it can measure, what statistics you can use, and the effect that your data and the statistics that you apply will have on your research design. So at a very high level, and we'll come back to this a little bit later on, but at a very high level, you have categorical data, which includes nominal and ordinal data. And then you also have continuous data, which includes interval and ratio. data. And so on the left-hand side, let's talk about categorical data. These are things like groups or categories. In terms of nominal data, you can think of things like gender, which has no natural order. You know, there's male, there's female, there's all different kinds of gender, other categories. You can think of blood type. You have the traditional ABO blood typing. You can be A, you can be B, you can be AB, you can be O, and there's no order to that. A is not necessarily different, you know, in a measurable kind of way to blood type O, and so there is no necessary order when you're thinking about nominal types of data. Then there's ordinal data, which has some kind of natural order. Satisfaction can be measured as low, medium, or high. And you can think of many, many other examples where there is a natural order to the data. And so for these categorical data types, things like frequencies, percentages, mode, chi-square, these are all tests that you can apply when you're using categorical data, whether it's nominal or ordinal. It allows us to classify or rank participants because of that. In certain cases, it allows us to choose designs that compare proportions, but it also does rely on very good design, and we should ensure things like sample size are accounted for so that the tests that we apply make more sense. When we think about continuous data, these are interval and ratio scales. And so these are numeric values that are measured on some kind of scale. And there are two types. The first one is interval scale, which is where the intervals between measures are equal. And so think about the difference between 4 degrees Celsius and 5 degrees Celsius, and 150 degrees Celsius and 151 degrees Celsius. The difference is 1 degree. It's equal. Even though the relative temperatures are vastly different, the difference is equal. So temperature is a very good example of an interval scale. It has no true zero value. In other words, you can have positive temperature and you can have negative temperatures depending on where you live in the world or where you are. And so it can be -1, -2, -3 degrees, and it can be on the positive side of that scale, 24, 25, 26 degrees Celsius, depending on your season and where you are. The other type is ratio, where there are equal intervals and a true zero point. And so here are things like weight and age and income, even though many of us would like the scale to be a little bit more negative and we would like the age to be a little bit more negative. In reality, those things have a true zero point and they can only be positive numbers. And again, this applies even to things like income, because they are equal intervals and they have a true zero point in the measurement scale. And so the statistics that you can use here are things like means, medians, standard deviations. We can apply things like t-test to looking at independent samples, ANOVAs, correlations, and so forth. The effect on your research design is when we're trying to understand measurement amounts, when we're trying to understand the scores on an index or a scale, or things like time, it allows us to compare these things and examine the relationships between variables. It also requires us to test assumptions to ensure things like normality, linearity, and homogeneity within variances. And so when we look at the data, it's not simply a matter of plugging in our data, calculating something and interpreting it in a particular way. It's got to ensure that our underlying assumptions about that data conforms to certain set things. So the type of data you use definitely determines what type of statistical techniques you can apply and the types of questions and answers you may ultimately encounter when we are dealing with different types of statistics. Now, the way your data is structured also determines your design and the types of tests that we can apply. So when we think about the different types of data, you can think of them as between subjects within subjects or correlational or observational data. And so when we think about between subjects, let's think about what that might look like in the real world, right? So it is when we want to understand the effect of something, we can compare them between two groups. We often in statistics call them two independent groups because they are different from each other. They are independent from each other. In the real world, this might be the dashed line on your screen here might be things like gender. On the one hand, you might have females on this side and males on this side. And what we're trying to measure is perhaps the influence of a particular type of medication. And you give the medication to both groups. For instance, you measure them once on each side for males and females on this side, and then you compare the results and you decide if gender was a factor that would give a meaningful difference between the groups because they are independent from each other. So the key point here is that you have two separate groups and they are measured once at the same point in time, and you compare the differences here. And when we do comparisons, things like independent sample t-tests, ANOVAs, chi-squareds become valuable to understand the difference between in terms of chi-square test categorical outcomes, in terms of ANOVAs when you have 3 or more groups, or if you have 2 groups, your t-test becomes valuable in comparing how the differences exist between those groups. Another way of structuring your data and your research design is to measure the same subject, but at different points in time. And so in the first example, you had 2 separate groups measured at the same time. In this example, you have the same subject, but they are separated by a time point. So person A will be measured at time 1. Something will happen. We will do an intervention, whether that's to change a factor or keep the factor the same, and then we'll measure them at a second point in time. And so the key difference here is that it's the same participant measured at multiple times under different conditions. And so the example here is that we can measure someone's anxiety level or blood pressure at time 1. We can either allow for the passage of time and do nothing, or we can introduce a medication at time 2, and then we can measure them at time 3 and see what effect the introduction of the medication or not introducing medication had on the relative blood pressure. So it's the same person, and we're trying to understand and compare the scores of the same individual across different time. And again here, things like paired sample t-tests, ANOVAs, or a Friedman test would be useful in terms of understanding how each measure differs across time. The last type of data structure would then be your correlational or observational data. Here, there's no manipulation. We are just looking at variables as they are measured naturally and as they occur. We can compare things like anxiety and blood pressure on 2 different scales, and we can examine the relationship or the association between these 2 variables over time. We often anecdotally think about anxiety increasing blood pressure, anxiety reducing the quality of sleep. And so we can measure different kinds of variables in this sort of way. And so here things like correlational data becomes important, regression analysis, whether it's simple regression or multiple regressions, become very, very useful. But the way in which you structure and design your research determines what type of tests you can use, and the type of tests ultimately determines the statistical power that your analysis may have. So we've looked at a little bit about variables. We've looked a little bit into the design and the elements of research. So how do we pull all of this together within a research process? Now, essentially, a research process starts with a problem. It can be a small problem, it can be a big problem, but it's a problem. And you can use that problem to define a research question. Now, there are many words on the screen, friends. We will unpack them all in the slides that follow. So don't be put off by things like variables and research design or data collection or whatever the case is. We start with a simple, clear question. what do we want to understand and how do we measure that? And so the research problem in this example on screen asks, is we have low voter turnout in local elections. That's the research problem. It is broad, it doesn't have any specifics. And so we convert that into a research question that becomes a little bit more specific and a little bit more measurable. And so we convert that low voter turnout in local elections into a question, which has a question mark at the end. And that is, how does access to polling stations or voting stations, depending on where you live, affect voter turnout? So in other words, does the number of voting stations influence how many people actually turn out to vote? And so when we unpack that in terms of a research process, we create a number of variables. We have an independent variable, a dependent variable, and in certain instances, not all, but in certain instances, we'll control for certain variables. So in our example here about access to voting stations and actual voter turnout, our density of polling stations, in other words, how many voting stations in an area, is our independent variable. Our dependent variable is the voter turnout rate. How many people actually come on election day and cast their vote relative to the number of either registered voters in that area or the number of residents in that area. And those are two very different numbers as a denominator. And then what we can do in certain instances where it's appropriate is to control for certain variables that might influence voter turnout. Here, things like demographic characteristics. For instance, in rural areas, the distances between voting stations might not be 1 or 2 kilometers. It might, in fact, be many, many kilometers where people do not have access to vehicles, and so they have to walk. And so that's a factor that would influence. Income is another one that we've got on screen here. So if you have access to higher income, in all likelihood, you have access to transport, and you can get to a voting station more easily. So what are the factors that can influence voter turnout, and where appropriate, we control for them using control variables? And so I've introduced 3 new words right now: independent variable, dependent variable, and control variable. We will unpack that a little bit later on. Don't be scared away by them. Stay with us. We then use these variables to integrate it into our research design. So variables, which is a word we'll unpack a little bit later on, influences our research design. These are the cogs in a gearbox, the gears that drive our research, the variables. And so when we convert the variables into implementable, practical research design, we ask the question, how do we measure this? And, we all have these wonderful ideas in our head where we want to measure certain things, but the how, the practical, becomes the challenge. And so in this case, what the researchers have decided to do is to use some kind of quantitative data. They will use correlational analyses where they'll look for relationships or correlations between 2 different types of data. And in this instance, they will use survey data and link it up with existing GIS data. And for those of you not familiar, GIS stands for Geographical Information Systems. It is mapping. That's all it is, mapped data. Okay, so let's understand what that looks like in terms of our data collection. So the research design translated to data collection, we have either a record of people who voted, which in many cases I think might be illegal, so we're not going to do that. Or we can have data collectors standing at polling stations counting anonymously how many people, not who, but how many people attend the voting station. So at the end of the day, we'll have a count of 5,000 or 10,000 or 20,000 people that accessed the voting station. We also have, from a national census, hopefully, the number of people that live in that voting district, or from that voting or polling station, the number of people that were registered to vote there. And so that would give us our denominator. So the number of people that actually turned up in the day over the number of people that either live in the area or that were registered to vote will give us an estimation of our voter turnout at that particular voting station. Then we will use geographical maps or census records to better understand how the number of people or the rate of voter turnout translates to polling station density, or the number of polling stations within a particular area. So we can map this data. We can say we had 10 people appearing in this location and 100 people appearing in that location. You often see this when you look at things like heat maps, where we've got the little bubble expressing fewer turnouts and a bigger bubble on the side where we see bigger turnouts of voters. And that visual representation gives us an indication of the relationship between the different variables: voter turnout on the one side and polling station density or distribution of voting stations within a particular area. And that's just one type of analysis we can do. There are different types of statistical analysis. We can use data visualization, as I mentioned, is one. We can do types of regression analysis. We can look at different types of correlations. Do more women turn out than men in particular districts? Is the average age of voter turnout younger people? Is it older people? Is it more employed people or unemployed people? Does the fact that it's a public holiday or not on a particular voting day make a difference to voter turnout? And there we can use things like historic and administrative records from that voting district to understand previous turnout in 1999, in 2005, in 2015, and 2025 to understand what may happen in 2026. So there's different types of analytics that can be done based on this very simple, but often real-world examples. And so, is our job done once we've done the analysis? My answer to that is no, because quantitative and statistical outcomes and analysis often is not very accessible to the public. It's not very accessible to the people that need to make evidence-informed decisions about voting, about polling stations, about the way in which we make voting resources available to citizens of South Africa, in my case, but your country, wherever you are from. And so they have a civic responsibility, a democratic responsibility to ensure that voting infrastructure is accessible to as many people as possible and also as widely spread, so that we increase polling station density, the number of polling stations within different districts. And we need to do that in plain language, because while we are scholars and researchers and academics and read, academic literature and understand what p-values and all of these things mean, it becomes important to interpret the results and create plain language findings so that our data can be put to meaningful use. And so this last box here about conclusions, the need to increase polling stations in underserved areas for greater voter turnout is an important message. How we get that to our policymakers, how we get that to our ward councillors or our traditional chiefs or the people that manage the infrastructure, in this case, voting infrastructure in our communities, becomes critically important. And so the important thing here is to convert our analytics into usable plain language findings. And that's the importance of science communication in this case. So, research questions and hypotheses. I told you we'd unpack each of these things. A research question really is an open-ended question that sort of guides your study. It defines specific focus on a problem, and it is generally framed as a question. In the example, we were interested in voter turnout and polling station density. So it really asks the question, what is the effect of X on Y, if you really want to boil it down? From an earlier example, we spoke about how does daily screen time affect the sleep quality of university students? It's a very broad question. What is daily screen time? Is it 20 minutes a day? Is it 2 hours a day? Is it 3 hours a day? What is sleep quality? How do we measure sleep quality? Where do we find a sleep quality? And which university? Is it a university in Egypt? Is it a excellent university in Accra? Is it a university in Johannesburg? The research question is very broad. It's very open-ended. And so to convert that into a research hypothesis, we need to make it more specific. We need to, in some instances, introduce a testable prediction. in order for us to answer that question. So a research hypothesis, therefore, allows us to, before we collect any data, to create a if this, then that type of question. And in our case about daily screen time and sleep quality, we asked the question, or we developed the research hypothesis based on the question, how does daily screen time affect sleep quality of university students? We hypothesize that students who limit their daily screen time to under 2 hours will report significantly better sleep quality than those with higher screen time. So the hypothesis is those that have lower screen time experience better sleep than those who have higher screen time who may experience interrupted or poorer quality sleep. And that's really the key fundamental difference between a research question and a hypothesis. The next interesting area that we need to understand is the difference between a population and a sample. These are big words that are often thrown around in quantitative methodologies. And so when we think about it at its basic form, and we can explore this in many, many different ways, in very much deeper ways, depending on your level of study, you will encounter these in different types of ways. But at its basics, a population is the entire group you want to study. I live in Cape Town, and so a population would be, in a certain sense, all adults in Cape Town. If we are only interested in adults in Cape Town that drive blue motor vehicles, then a sample would be a specific, smaller subset chosen from within the bigger population. And you can see the population is made up of different people, males and females, people who identify as male or female, or others. You have people that are tall, that are short. Some of them wear spectacles. Some of them apparently have no eyes. Some of them wear their hair up, and some of them wear their hair down. And so you've got different types of people. And what we want to do is ensure that when we create a sample of interest, and in our case, we are interested in people that drive blue motor vehicles. We want to get as many people from different groups that represents the population. So the sample is a specific, smaller subset chosen from that group of people. In our case here, people with blue cars that live in Cape Town. And you will see we have men, we have women, we've got different race groups, some people with beards, some people without, some people with eyes, some people with not. And so we balance off that sample to ensure that we have an accurate representation of the broader population. Because if you remember at the beginning, we said that within quantitative statistics, we use a smaller sample as a subset to make inferences about the broader population. And so we will use this group of people that drive blue cars to make some inferences about the bigger population of people in Cape Town that drive blue cars. But when we do sampling and when we do these kinds of statistical procedures, it does encounter error. And so a population is made up of many, many thousands of people, some cases millions of people, or hundreds of millions of people, depending on where you live. And so people come in different shapes and forms. You have tall people and shorter people. You have men, you have women, you have people that are differently able. Some are not, use wheelchairs and assistants. Other people are a lot more active. Some people identify as men. Some people identify as women. Some people have different gender classifications. Some are old, some are tall, some are short. Apparently, some have tails, according to AI generation. And so we have different types of people in a population. And when we draw a sample, we want to get a good representation of all of these people. And so many of you might have been to an arcade where you have a big group of fluffy toys in a puddle, and you have this arm that comes down and collects one and drops them in a bin, and you spend much of your money and much of your youth trying to win one of these little plushy teddy bear toys. Sampling is very similar. It goes into the population and it identifies people that might be a good representation of the entire population. So when we look at a sample from a population of, and let's just use smaller numbers because it's easier to grasp, about 10,000. 1% of that would be 100. And so we take a random sample from the population, and you can see within this bucket where we are drowning our sample, you have blue people and orange people and shorter people and older people and younger people, those that wear dresses and those that don't, those that think of themselves as male and those that think of themselves as female. And that gives us a more or less good representation of what the population might look like. And so we call that the population parameter, this little graph at the bottom. That's what the population looked like, a more or less normal distribution. You have sort of, fewer people on each end, and then the bulk of the population kind of sits towards the middle of that population parameter. But when we do sampling, no sample is absolutely perfect. Sometimes people might have a particular political leaning. They might have a particular view on xenophobia. They might have a particular view on sport. They might have a particular interest in youth issues. They might have a particular interest in short people issues. Whatever their particular individual human characteristic might be, it comes in the form of a sampling error. And these are really fluctuations in the characteristics of the sample that deviates, that is different from the population parameter. So if our population has a beautiful curve like this, at times our sample means might look like that, or it might look like this orange line, or it might be a bit flatter, like the second orange line, or it might deviate from the mean in terms of this blue line here. And what we are trying to do is chase this elusive, beautiful bell curve that we see in the general population, and to reduce the measurement error as much as possible, so that we shift each of these sample statistics to conform to some way, shape, or form to population parameters. It's not always possible, depending on the size and scope of your population and what you're trying to measure, but as close as possible to reduce the amount of sampling error would be the ideal situation when we think about what it means to sample from within a population and reduce the sampling error. And the key here is that if we are going to measure the interest of women in a certain thing, then we shouldn't go and talk to men, right? The basics, fundamental thing. If we are interested in youth views on something, we shouldn't go and talk to 80-year-olds. We should talk to 18-year-olds. And so the number of 80-year-olds in our sample would be an indication of sampling error. The number of men in our sample of that's meant to be women is an indication of sampling error. Those are very obvious types of sampling errors. There are more subtle types of sampling errors, and we'll deal with that on the next slide once it transitions. There we go. So we talk about representativity. When we have a population, we've got different types of people. We covered some of this on the previous slide. So in a sample of 10,000, as I mentioned before, you've got orange people and blue people and, young and old and so on and so forth. And each of these people represents a different type of person, a different member of the population. And like I said before, they each come with their own sorts of views. And so how do we get to this wonderful, beautiful, predictable bell curve, which is not without its challenges, but how do we match the population parameter, so to say, the way that the population looks when we take a sample of, say, in this case, more than 1%, 10% of the 10,000 sample. We look at a sample of 1,000 people from this population of 10,000. How do we ensure that they better represent this population? And so to do that, we have to understand the different characteristics of the population. And here we can think of, many of you are from South Africa. So things like age, things like gender, things like socioeconomic status, income, things like race. In South Africa, race is still a very big predictor. In other countries, it's not as much the case. So when we think about how do we do this, we have to balance for different things in a population. We look at what the population statistics are for, as an example, age, gender, location. I mentioned race. And we then match that to what we would like to see in our sample. So we get a proportional alignment or kind of representativity to ensure that our sample statistics meet what we look at when we try and come towards the population parameters. Now, I see there are some questions in the chat. Zakir, do you want to just take 2 or 3 minutes to lead us through taking some of those questions, and then we'll move on to talking
Okay,
about variables?
sure. So so I said we'll take questions after this slide. Okay, so the first one we have, if the population size is not known, how do I select my sample size? In addition, how do I justify the selected sample size and whether it is enough?
So, firstly, I'm not a prof, but thank you for your vote of confidence. There are going to be times when the population size is unknown. Then we have to rely on estimates. And there's a word we love to use, which is the best estimate. What could this population look like based on other locations, based on previous research that was done, hypothetically in South Africa? Sometimes you just won't know the population. I'll give you an example. My work focuses on science communication. So very often I work with a relatively unknown population of scientists in South Africa. Now, how do you define a scientist, right? It's someone with a postgraduate degree, more importantly, involved in the process of knowledge creation, very often employed at a university, a science council, a research lab, whether it's the public or the private sector. So those are the types of characteristics that we are looking for when we break down this concept of a scientist. And so when we go and measure attitudes towards social media amongst scientists, we then go to universities, science councils, research institutions, and we try and understand what their populations look like. How does it look like at the MRC? What does it look like at the HSRC? What does it look like at Sol Plaatje? What does it look like at the University of Pretoria? What does the researcher normal population parameters look like? And is there a way to compare them? To say the HSRC kind of looks like Sol Plaatje in this sense because many people have PhDs, 52% are female, some of them work in the human sciences, some of them work in the social sciences. We then begin to understand shared population parameters, and that will influence our representativity and our alignment in terms of our sample statistics. It's not always clear cut, right? When we are busy with population level data, we can turn to things like the national census. In your country, in South Africa, that data is readily available, and that will help us to do that. There are also ways in which you can use statistical measures of power to understand what your sample size should be. And I think it extends a little bit beyond what we are talking about this morning. And to the person who asked this question, I recognize your question, but I don't want to lose our colleagues. So I'm going to ask Van Dudzai to come back to the idea of statistical power and trying to understand how sample sizes are calculated, and we'll definitely answer your question in the second session this morning. Zakir?
One last question, because this one isn't. So if you've got a sampling or population question, we're going to move it into the next session because Dr. Van Dudzai will be speaking about this again. Just for now, we have a question. Can you please explain the difference between a control variable and confounders?
So I'm again thinking, is this appropriate to talk about here? So confounders tend to introduce elements into your research that in a way affects the logic of what you're trying to understand, right? And you control for those things usually. So if you know that income might be a variable that you need to control for because income determines access to education, income determines access to transport, and therefore, in our example that we used earlier, voting stations, you control for those things. And then the variable that you are actually interested in is voter turnout and polling station density, the number of polling stations in an area, becomes a little bit clearer. It's not as a result of the fact that people have cars and can drive to that voting station. It's not as a result of the fact that certain political parties have arranged a bus and have brought people to the polling station in that particular area. So voter turnout can be a factor of a number of different things. And when you control for the confounding impact of different variables, you can eliminate some of them, understand that they are there, but eliminate them and understand what the impact is of your particular variable of interest. So if your variable of interest is the number of voting stations in an area and how that influences voting turnout, you control for certain variables, you park them to the side and you come back to them at a later point. And that will answer your research question a little bit more clearly. For instance, in our example earlier about screen time and quality of sleep, many things affect quality of sleep. If we have too many energy drinks, if we smoke, if we have a lot of anxiety in our life, for instance. And so all of these things can affect quality of sleep. And if we don't control for them in our measures of screen time and its effect on quality of sleep, they might confound our findings in the end. And so they are related, but we'll come back to them in the second part of our presentation.
Very cool. I think in the interest of time, we'll move along. There are still questions on sampling, but please, guys, we will discuss it again later, so we'll pick it up then.
Fantastic. Thank you, Zakir. Yeah, there are so many questions that would come up here because sampling is a very big area. It's a very important, critical part of any research process, and getting it right influences how and what you can do with your data. So I'd understand that there are so many questions. We do only have a limited time to get through this, colleagues. So we'll move through it. We'll come back to any questions you have later on, and we'll try our best. We'll obviously make our contact details available to all of you. So should there be any questions, even after the session, I, for one, would be happy to answer them, and I'm sure my colleagues would be as well. Then another foundational element within designing good research is understanding what variables are. It is a characteristic, a number, a quantity that can be measured, number one, but it's also changeable. So then the values change across different people, objects, times, events. And here there's a little table on the screen which lists different types of variables, common things that we all encounter in our research: age, income, gender, life or job satisfaction, trust in science. A common one is smoking status. And so we can measure variables in different ways. Age is a very interesting one because we can either measure it at the level of exact age. I'm 18 years old, 19 years old, 20 years old, or we can measure them in groups and buckets. And this makes a difference to the types of analysis and the way in which we're going to have to clean and look at our data in our analysis phase. But the buckets can be: I am between 16 and 24 years old, 25 and 34, 35 and 44. And you can have different groups of things. Things like income can be grouped low, medium, high. Very often it's a variable that people don't like to share information on, and so I prefer not to say, or not applicable category is often included. Gender and race are also some of these variables where you can have specifics like male, female, or binary, or different types of gender. Same thing with race, but then there's usually also a category for not applicable, because people tend to be a little bit different, in terms of these types of variables. Satisfaction, whether it's job satisfaction, life satisfaction, and you can measure these on a scale numerically, or you can have categories like low, medium, and high. Trust, very similar. Smoking status, you can be a current smoker, a former smoker, or a non-smoker on the other hand. So defining the variable is what I'm trying to bring home here. If you're going to define your age variable as a specific absolute number, 18, 19, 20, you're going to have many categories. I mean, reasonably between 1 and 99 or 100 years old, you're going to have 100 categories for age. Or if you blend them into groups the way it's been done here, you can reduce the number of categories but you can also meaningfully introduce different types of analytics that will allow us to compare 16 to 24-year-olds or 25 to 34-year-olds more easily. So the precision, number one, but also the dexterity with which you can reasonably or easily compare categories is defined in the way in which you define your variables. So any statistical analysis is influenced by the way in which you define your variables, how it's collected, how it's measured, and certainly, as I've just mentioned, how it's interpreted will be influenced by the way in which you define your variables. And so there are different types of variables. You have independent variables, dependent variables, and certain designs look at control variables. These will tell us in some ways the cause or the predictor of some kind of change within a measure between certain points or between different groups. The dependent variable, which is the thing we are interested in, what we are measuring. In our example of polling stations, the density or the number of polling stations in an area was our dependent variable. And the independent variables were things like the voter turnouts. And in that particular instance, we controlled for different factors like income or transport or different types of things. When we think of variables, there are two types. You have numeric and you have categorical. And we've touched on this a little bit earlier when we spoke about the types of data. But continuous variables are things that are measured on a scale, like height and weight. Discrete variables are things that are countable as whole numbers, the number of cars, the number of books, the number of cats in a particular area, if we are counting populations. Then in terms of categorical variables, you have ordinal variables, and these can be ranked in a particular order, educational level, and things that have a particular order and a ladder in which they continue. And then you have nominal variables, things that don't have any particular order. We spoke earlier about blood type, and we'll come back and use that example here again. There's no particular order in terms of these variables, and you can understand from things and how they differ. Height is very different to blood type. Weight, even though it also forms part of a can be used within a medical sense, is very different to blood type. You can measure and compare different types of weights, but comparing blood types is not really something that's done. You can compare people with different blood types and link that to other types of variables, but the ABO type of blood typing is generally not compared. And so the type of data that you collect and the way in which you define your variable becomes very important, because that determines what type of analytics you are able to use. And so we've all heard these words being used earlier in the presentation, and I'm sure in your lives you've heard the words descriptive statistics and inferential statistics. And just to unpack them a little bit here, descriptive statistics really summarizes and describes a data set. It's the bigger picture. What's going on here? Inferential statistics uses a smaller sample, a smaller group of that sample to draw conclusions and to make, in certain instances, predictions about the bigger population. So if we think about the data, the types of statistical tests, the key questions, and some examples, descriptive statistics generally talks about the population or the full sample that we are interested in, whereas inferential statistics takes a smaller group or subsample and applies analytics to try and answer particular questions or draw particular inferences about it. And so when we talk about descriptive statistics, these are things like totals, sums, averages, standard deviations, the high-level types of stuff. It answers the question, like, what does the data tell us here? What's going on here? What are the bigger things? What are the patterns that we are observing? It doesn't give us any certainty. It doesn't tell us about cause and effect. It doesn't tell us about what might happen in the future. All it tells us is about what's going on here. And how do we make sense of this? How do we put this in some kind of thing? And an example here is calculating the average test score for a specific class of students. Very basic, gives us a big picture of what's going on. Some people will score very high, some people will score a bit lower, but on average, what's going on in our class? When we look at inferential statistics, we've got things like correlation, regression, t-test, ANOVA. These are all sort of bigger statistical concepts. It tells us, sort of what can we infer from this little subset about the broader population. It gives us things like probabilities. It tells us about uncertainty and error. And an example here is generally on a bigger scale, bigger than the class. If we survey 1 million voters, can we reasonably predict the outcome of a national election? Different answers to that question. We're not here to give you any answers, but that's the type of scale that we are working with. We're looking at a subset of a population, in the case of South Africa, more than 65 million people. We're looking at 1 million voters to try and predict what the bulk of the population will say based on inferential statistical analytics. And then as we come to the end of this first session this morning, we need to talk about ethical considerations. What does that mean when we're working with quantitative methodologies? Ethical considerations is something that many researchers look at, and they kind of shake their heads and they try and figure out what this might look like. Now, this wheel might look very different where you are, but they all share similar aspects. And the major part here is that it exists to protect you as the researcher, your institution, but also the public that is dependent on the data that you are producing. So it looks at the integrity, it looks at issues of equity, and it also takes into account the social responsibility that we have as data producers to ensure that our research conforms to certain guidelines. And the key pillars here includes things like ethics committee review, RAC review, informed consent of your participants, protecting respondents' privacy, not disclosing who they are, and especially with sensitive research areas like in medical research or voter research, this becomes particularly important. Data governance, making sure that there are rules that determine what type of transparency you have in terms of use of your data, secondary use of your data, that your respondents know this, that when you're collecting data in the field, you say to people, we are using this data for a study on the effect of screen time on sleep quality, but we will also use it in the future for that, or we will not use it in the future for that. And when we make those promises, to stick to them. So data governance really is an important aspect, and increasingly so as we live in a world where data is increasingly accessible in digital formats. Preventing bias in sampling is something that a lot of the questions were related to earlier, and as algorithms take on a more important role in this area, preventing bias that is introduced due to algorithmic issues becomes very, very important. I spoke about transparency earlier, ensuring that we provide feedback, that we are accountable to our participants and our research stakeholders, and ensuring that those that have reasonable and privileged access to the data do so responsibly, and those who would like reasonable and privileged access to the data are suitably vetted and checked out, so that the data that they use and that they access is not abused in a way down the line that does not conform to the expectations of our data providers, of our participants, but also that it conforms to all data governance principles that we've laid out in the very beginning of our research process. So as we come to the end of this first session, we'll continue after a little break. We look at, what are the foundations of quantitative research? And this opening session really spoke at a very foundational level about what quantitative research is. And at its core, there's 5 sort of key messages here. The one is that it begins with good questions. Think about your questions. What is it that you want to know? Has it been done before? Is the existing data? How do we operationalize this? Begin with good questions. What is the concept we are trying to measure? What does it mean to have screen time? What does it mean to have good quality of sleep? How does it affect what does it mean when we think about university performance? Is it only grade scores or academic outcomes? How do we define some of these things? So good questions inform good research. Statistics, as powerful as it is, depends on good research design. So design your research ethically, design your research thoroughly, ensure that you answer and ask the critical and difficult questions. As we've all come to know, quantitative research uses numerical evidence, and how we put that together determines the types of analysis and analytics we are able to do. So always keep that in mind when you begin to plot your good questions, is what does the data look like? What do I need to be able to say, and how do we structure our data and variables in a way that will allow us to get to those, to answer those particular questions. The driver here is defining your variables correctly. It's the cogs, in a way, on the image here. It's the cogs that drives good research. So ensuring that our variables are designed in a way that is meaningful, that speaks to our research questions, that leads towards better understanding how we can come up with good statistical analysis is very much dependent on setting up variables in the most appropriate way. And this, in many ways, will lead to better answers. Not the answers, but better answers, because answers start to create new questions, and new questions begin to explore the data again. So it's very much a cycle. So start with good questions to get good answers, and the processes in between will help us define what that means. So Zakir, I'll ask you to just paste a link in the chat, but we'll do a little fun exercise. And yes, sometimes the word fun can be put alongside quantitative research. Zakir has dropped a link in the chat to a Google form. It'll take, or you can scan the QR code currently on your screen over here if you have a mobile phone next to you, if you're not using it to attend the session. Use the link in the chat, scan the QR code, or you can type it in if you really want to type it in to your browser. You will arrive at a Google form. There's a little paragraph, answer the paragraph. There will be, read the paragraph, think about it for 2 or 3 minutes, and then there'll be a few questions you can answer. There's a consent question. There is a few demographic questions asking you a little bit of anonymized information about who you are and where you come from. And then there's about 4 or 5 questions related to the paragraph that you will read that will cover some of the topics that we explored together this morning in this broad introduction to quantitative research methodologies. And then we'll continue. After that, we'll explore some of our responses together. We will all, 200 of us, put together our responses and look at the data set, and we'll explore that together. Zakir, will take about 5 minutes or so, and then we'll come back. Over to you.
Okay, so we were supposed to end the session at 10:30. We are running a bit over. What I'm going to suggest is, can we break now and then come back at 11:45? Is everyone fine with that? We were going to 30-minute break. Are you fine with that, Sai? And then
Yeah. Okay.
I'm going to okay, cool. We'll come back. I'll discuss with you outside of here what Edward did say, because we're gonna have to okay, cool.
Not a
So
problem.
everyone fold that out. When we come back, we'll go through the results and continue with Dr. Parker's session, and then Dr. Bandutsai will come in right after that. Okay, thank you, everyone.
Recording stopped. Yeah,
Hello,
hello.
Clement.
Yeah, moderator. Sorry, I just wanted to ask about the evaluation form, the session evaluation form, or are we gonna do it at the end of these
It will
months?
be at the end, so it will be the whole block 9 to 1, not the separate
Okay,
section.
I understand
Okay.
it now. Thank you so
Okay, I'll
much.
send it towards the end. Thank you.
All right, thank you.
Okay, it's 10:45. So I hope everyone's
Recording in
back.
progress.
If they've left, I hope they will return, but I think we can get going again. Sire, if you want to continue.
Thank you, Zakir. Thank you, colleagues. Thank you for making your way back. Let's look quickly at some of the data that we as a group managed to put together. Hopefully on screen you are seeing this little web page. We had 58 responses. There are just shy of 200 people in this group, so that's about a 30% response rate. 58 people responded, 98% of you agreed, consented to participating. It looks like one person or so didn't agree to participate, and so in a sense, their data would have to be excluded from what we are looking at here. Mostly female participants compared to males. Age groups generally older than 25, with quite a big proportion sitting here in the 40 plus group, 34% or so. Most people attending from South Africa, with a few from the Southern African region, and then two from West Africa. Welcome to both of you. In terms of the responses to the quiz items, the orange represents the correct answer in this case. It is all undergraduate students at a large Western Cape Public University. That's the correct response to question number 1 in terms of the research population. Almost 90% of you got that right. The research sample is the random sample of 200 participants. Again, near to 90% of you got that right. The primary outcomes or the dependent variable in this case would be the stress scores and the average academic scores. 71% of you got that right, and 14 or so selected sleep duration and academic year, which was not the correct answer. The next question, the main research question, is does self-reported sleep duration predict perceived stress and average academic scores amongst undergraduate students? And again, just more than 90% of you got that right. And then the expected outcomes that the researchers expect, 85% of you got that correct, which is shorter sleep will be associated with higher stress and lower average academic scores. And that was selection B. And then we snuck in this little question here at the end. Looks like most of you are enjoying this session, so thank you for sharing your answers. 61 people have now submitted their responses to the online quiz, and we are appreciative of that. Let me just get my presentation back online, and then we can continue. We do have a challenge with time this morning, and so if I can just share my screen, we can then continue with the second session of the Foundations of Quantitative Research. And we will deal here very briefly with issues of measurement, validity, and reliability. These are quite important concepts. By the end of this session, you will be able to navigate some of the challenges that we have encountered here. I think my slides have jumped a little bit forward, colleagues. If you give me 1 second, I'll bring them back to where they need to be. And there we go. Session 1.2. Let's continue from where we left off. We will start here and just talk a little bit about the learning objectives of the session. We've already discussed how to define variables, what distinguishes variables apart, whether it's independent or dependent variables. We had a lovely question about control and confounding variables. We also explained the difference in measurement scales. In this session, we'll talk about validity, reliability, and also come out of the session with a better understanding of why measurement quality matters. And I think that will be the important learning outcome that comes here. So let's begin there. Why does measurement matter? And I remember always having been taught that if you cannot measure it appropriately, you cannot analyze it correctly. And so the key message here is that no statistical test will get you out of badly worded questionnaires, a bias scale. Essentially, statistics cannot fix bad data. So quantitative analysis starts at the very beginning, defining your research questions, as we mentioned earlier, but also designing an instrument that speaks to what you intend to achieve, and therefore ensuring that your statistical options are supported by the way in which you measure. And so doing it wrong really has consequences. It will lock you out of your data. It will lock you out of the correct analysis. So the precision of your measurement tool influences how you are able to use your data. And if it's done incorrectly, you will have meaningless conclusions. So validity is the foundation of research credibility, and reliability ensures that your findings are repeatable. It removes the noise. It enables you to balance the two, validity and reliability, ensure that your measures are both doing what they're supposed to be doing and doing it time after time. So when we talk about quantitative research, there's this higher order level of things which are concepts, and then there are things which we call variables. So concepts are things like trusts and stress or motivation, things that exist in textbooks, in theory. Variables, on the other hand, are measurable, right? So we can't find a trust and we can't find a stress, but we can develop a trust score. We can develop a stress scale, and we can look at indexes or indices that measure things like motivation. And so how you define your construct will really determine what you are able to do in terms of measurement. So if we think of something like income, it's very abstract, right? You can define income monetarily in terms of currency, be it South African rands, US dollar, kwacha, pula, whatever the currency is where you are from. But you can also define it more precisely in terms of monthly income in South African rands. The global standard these days tends to be things like monthly income in US dollars, and we apply a certain rate to get a conversion, because that means all the measures then are standardized as a US dollar, in this case as a South African rand. It is the concept that informs your research interest. We are interested in the effects of income. But the variable, as South African rands on a monthly basis, is the reality within your data. It's what we are able to measure. It's what we are able to manipulate. It's what we are able to more accurately encounter. And how you define a variable really determines what you can conclude within your data. So as an example, an abstract concept like motivation could be measured with a single yes or no question. Do you have motivation? Yes or no? And you can then say 50% of my sample has motivation and 50% said no, they do not have motivation. That's pretty much all you can say with a simple yes or no type of answer, unless you link it to other variables in your data set. But when you use a different type of measure for motivation, in this instance, you say a validated 10-item index that deals with motivation and different aspects of motivation, and when taken together as a index, tells you something about the level of motivation of individuals and groups of people within the sample. It yields completely different data. So the key lesson on this slide, colleagues, is that your results are only as good as how you define your variables. If it's simply defined as a binary yes or no type of question, the use cases are limited and the power is limited. But if you define it more broadly, if you use multi-item indices, it will give a different dimension to your data. It's not always possible. Certain things like omnibus surveys, for instance, charge you per question that you include in their survey. And it's quite expensive to survey at bulk in that kind of way. So fielding many questions, 100 or 200 questions, might not be financially feasible for your project. On the other hand, there might be items that are more important than asking things about motivation. And so you have to balance off how many items in your questionnaire, which items you include, which items you exclude, the scope of the items. Is it a multi-item index or a single binary type of response? And that will determine how you can use these variables. The next element in terms of the foundational elements that we are talking about here, remember, these are just foundational elements. There are many, many questions that will come from some of this, and we'll deal with that in the next session. But level of measurement dictates how and what you are able to do with your analysis. As an example, you can't apply averages to nominal data. You can't use parametric tests on ordinal data. Just not possible. When you use continuous data, you unlock a lot of different tools that you can use. And so, as an example, when you're trying to look at income, you won't necessarily use a pie chart. Or when you're talking about gender, a scatter plot just doesn't make sense. And so the level of measurement influences how you can analyze the data, and more importantly, how meaningful you can visualize the data. And in a world that's becoming multilingual, where science communication has a significant public impact, you have to design your outputs of statistical analysis, your visualizations, your representations in a way that is designed for a multilingual world so that it is accessible by people. And the key message here is that level of measurement doesn't just affect your analysis. It defines what conclusions you are even allowed to draw. So look at this table at the bottom. The different types of data, nominal, ordinal, interval, or ratio types of data. When we look at the first category of nominal data, these are categories with no order. Remember, we spoke about them this morning: gender, ethnicity, simple yes or no's. Here you can do things like bar charts, pie charts, that sort of thing. The statistics that are applicable here when using nominal data, generally, not exclusively, generally would relate to frequencies, proportions, chi-squares, that type of thing. When you're using ordinal data, and here, these are data sets with clear order within their structure, educational level, Likert scales that start at 1, go to 5, from 5 to 1, whatever the case may be. Bar charts, stacked bar charts would become useful here for visualizations, and median, percentiles, correlations. These statistical tests would be valuable to use in terms of ordinal data generally. There are exclusions, obviously. And then interval and ratio types of data. These are numeric values with meaning attached to the differences, like the difference in age or the difference in income, or test scores. Certain scales have meanings between the different scores. And so here things like histogram, box plots, scatter plots are opened up. There's lots of different visualization techniques that can be used when you're using this type of data. And statistics here become important, things like mean, standard deviations, correlations, t-tests, regressions, that sort of thing. So the type of data that you define within your variables influences what can be used, and what types of tests can be applied, and what types of visualizations can come out of that. So it's very important that you consider the level of measurement when you designing items for a questionnaire, and think about what analytics would look like from the very get-go. Often we get a data set and then we think, oh no, what should I do now? The correct way of doing this is to design your analytical strategy when you are developing the base, your questionnaires, your research questions, your hypothesis, because informing it at that stage will make it much easier once you get to the data analytics. When we think of validity, the basic question here is, am I measuring what I think I am? That sounds like a silly question, right? But often we do silly things. We think of that first bullet point there. It's like measuring intelligence by the number of books a person reads in a given year. So if I go around asking a question of people and say, I'm looking at measuring intelligence, how many books have you read this year? I might not be measuring intelligence, right? I might be measuring free time, because you need a lot of free time to read. I might be measuring people that are pursuing some kind of academic goal and therefore they're reading a lot more. I might be looking at people that have a little bit more money because buying books is quite expensive today. And so, you have all of these variables that you need to control for, but definitely the concept of intelligence doesn't relate very well to the number of books read. So it comes back to this notion of validity. Am I measuring what I think I'm measuring? There are 4 types of validity: face validity, content validity, construct validity, and criterion validity. If we group them broadly, content and face validity is your foundation. It tells us at a point, is this measuring what it's supposed to be measuring? Do we cover all the conceptual areas related to this? While construct validity thinks about, what does the theory say? Am I covering all the aspects? And then criterion validity tries to connect all of this with real world examples, things like showing that a stress scale correlates to blood pressure readings. When we look at face validity, what does it mean? It basically asks, does this questionnaire look like it's measuring what it should? Am I talking about elements of intelligence rather than elements of income, elements of free time, elements of other things I spoke about earlier? Generally, it's sort of an informal check. It's useful in pilot testing. It's useful for checking that questionnaire design. It's checking that the items that you've used generally conforms to the expectations. Content validity takes a deeper dive. Does the instrument cover all aspects or all concepts that are being spoken about here? If we're thinking about knowledge test or complex concepts like intelligence in this case, do we cover all areas of intelligence and only the areas related to intelligence directly? And that's what content validity does. It checks that what is in your items, your research items, actually relates back to the concept that we are most interested in. Construct validity looks at, does the instrument actually measure the theoretical construct it's intended to? This is really the gold standard. If you have construct validity, it speaks volumes. It is crucial for broad and abstract concepts, especially like intelligence or job satisfaction. I see in the chat we had a question here. Is it possible to measure performance for workers? I imagine you mean job performance. Yes, it is. You would then have to design an instrument that specifically looks at how do we measure job performance? What are the key attributes, the key performance areas of a particular job? How well do participants, to workers, conform to those key performance areas? And then we develop some kind of metric to say these workers perform better, these workers are meeting the standard, and these workers are maybe not meeting the standard and need some kind of intervention to help them perform better or outpace what the key performance areas are. And then lastly, colleagues, we talk about criterion validity. And this asks the real world question: does the instrument predict or correlate external outcomes? So, for instance, if we have face validity, content validity, and construct validity in a questionnaire that measures job satisfaction at a company, to use the example that was asked in the chat, if we use this in an applied setting, we then ask the question: does our questionnaire that measures job satisfaction or worker performance predict real world outcomes? Is there a relationship between when people leave an organization, we call it turnover, the turnover of staff, the job turnover. So is there a relationship between job turnover and worker satisfaction? The more satisfied people are, the longer they stay in jobs, or the less satisfied people are, the more quickly they contribute to the turnover or quitting rate within the organization. Similarly, with worker performance, do high performers stay longer and show higher satisfaction, or do low performers tend to leave the company sooner and show low satisfaction? And so criterion validity really looks at some of these more deeper predictive elements, and it's really used in the applied diagnostic sort of medical setting more frequently than it's used elsewhere. When we talk about reliability, so validity says, are we measuring what we intend to measure? Reliability says, can we do this time after time? Is it consistent? So it's about the consistency of a measurement. Do we produce the same result time after time, assuming the underlying conditions are the same? Now, an example here, a good example here would be something like a bathroom scale. You step on a bathroom scale, it gives you a number, you get off, which is what I often do. You get on again, it gives you the same number. You get off, you get on again, it gives you the same number. And then me personally, I wonder why the number is so high. But if the number is accurate, we shouldn't question it. The bathroom scale should consistently give you the same number time after time, assuming it is a valid number. A thermometer is another one, probably less prone to my boring jokes, but a thermometer should give you the same reading time after time, irrespective of who is taking the reading. Now, you have to control for certain variables. If I hold the thermometer, the heat of my hand is going to influence the reading. So you have to exclude any, what our colleague said earlier, confounding types of variables. And today we use less than chemical thermometers, we use laser thermometers, right? And so if the person taking the reading and all other noise or all other interference has been removed, we should get a similar temperature reading, irrespective of who's taking that reading. So that's a reliable measure. If your data comes from a single survey, then we use a reliability check called internal consistency. If you measure people twice at different points in time, we can use a type of reliability measure called test-retest reliability. And if you have multiple people scoring and interpreting data checks, we can then use a type of reliability measure called inter-rater reliability. So what do these mean? Internal consistency really checks whether all items on a scale is measuring the same underlying construct. Are all the questions talking about intelligence? Are all the questions measuring anxiety, or is it measuring something else like sleep deprivation? Is it measuring things that are not related to anxiety? There are statistical tests that you can use to infer whether your items in a scale are all measuring, in this case, anxiety. Cronbach's alpha is a very popular one. It is a number between 0 and 1, and the closer you get to 1, the higher the overall reliability of the items within that particular scale. And all it tells you is that the 10 items, in this case, are measuring anxiety. It's measuring the same underlying latent concept. And like I said, the closer that number gets to 1, in this case, it's 0.85 as an example, the better the overall reliability in terms of internal consistency. The next type of reliability is a test-retest methodology, and this really tells us, is the test stable over time? So if we are testing cognitive abilities here in this case, we measure the same group of adults twice, once this week and once in 2 weeks' time, and we compare the results. Generally, people's cognitive abilities don't change over a 2-week period, and so we expect that there should be a relationship between test 1 and test 2 if we are measuring the same group of adults. And here we would use a correlation. How well do the scores between week 1 and week 2 correlate? It's also a number measured between 0 and 1. The closer to 1, the higher the correlation. And it proves, the closer to 1, it proves that this test is stable over time and over multiple points of testing. So test, retest, exactly what it says on the packaging. Inter-rater reliability, another one of those ones that tells you what it is on the packaging. If you have different observers measuring something, or different people, for instance, marking an examination script, they should come out with relatively similar scores, if not the same score, if it's based on a strict marking regimen. So if I mark you in an exam and Zakir marks you in an exam, and there's a good guide as to how you score marks on this exam, then we should relatively come out to a same or similar scoring item, and that gives us good inter-rater reliability. In a practical clinical sense, if 2 doctors independently look at an X-ray and they come up with the same conclusion, it shows that the measure is independent of Dr. X versus Dr. Y. In our case, Zakir and I even though we did these assessments independently of each other, we came up with the same score, reliability, we found that the measure was reliable. And there's a statistical test that you can use and you can employ if you're using inter-rater reliability. It's a kappa statistic, and it shows that the measurement or that the outcome of the measurement was in fact stable and therefore reliable. So when we talk about validity and reliability, we often like to use this target shooting practice scale on the right-hand side of your screen. On the one hand, reliability is necessary, but it's not sufficient. Validity is also important. When we think of reliability and validity, let's think about it as a target shooting range, right? And assuming the blue dot is valid, is the point of validity, and the way in which we cluster our shots is your reliability. So time after time, we are able to shoot in the same spot, and that spot should be the center, or what we know as the bullseye. In this example, upper left, where my mouse is rotating at the moment, you'll see that the shots are all above the center line, but they are nowhere close to the center. So it is unreliable in that they are all spread across 2 quadrants of the circle. And they're not valid because none of them are close to the center bullseye point at all. If we switch to the upper right-hand side of the diagram, we'll see that our shots are all over the place. Some of them do get close to the middle. Some of them, like these ones over here, kind of touch the middle. They don't hit the bullseye, but they do get close. And so there's a degree of validity because it's approaching the bullseye. But it's unreliable because any shot has the ability to hit any of the 4 quadrants. So unreliable, but somehow a little bit valid. On the lower left-hand side, we've got an example of what is reliable. The marksman, the sniper, the shooter in this case, is quite reliable. He's able to land all of his shots at this, what we would call on a clock, the 2 o'clock position. But is it valid? Is he hitting the target? And I don't advocate for any kind of violence. Is he hitting the bullseye of the paper target in this case? No, he's not. He's quite far away. So it's reliable in that he's able to group his shots into a tight-knit position, but is very far from the bullseye. And so it's reliable, but it's not valid. And on the lower right-hand side of the diagram, you have an example of what it means to be both reliable and valid. Valid in the sense that all his shots are either in or close enough to the bullseye, and all of them are clustered in a way that means time after time, shot after shot, accounting for wind direction, humidity, and all the other things that we learn about in Hollywood movies. The sniper is able to hit the center of the paper bullseye target time after time. So he's both reliable and valid. And if we look at this, because none of us are snipers, hopefully, none of us fire firearms on a daily basis. So what does this translate to in real life, right? So coming back to my very untrustworthy bathroom scale, if I step on the scale and it reads exactly 2 kilos too heavy every day, which is true, it reads 2 kilos too heavy every day. So it tells me I'm 72 kilos when, in fact, in my heart, I know I'm closer to 70 kilos. Is it reliable? Yes, because it's telling me day after day, I get off, I get on, I get off, I get on, and it keeps telling me I weigh 72 kilos. It's reliably giving me an answer of 72 kilograms. Is it valid? I will leave you to decide. I have measured myself on other scales, and those have reliably told me that I'm closer to 70 kilograms, and so my scale is off somehow by 2 kilograms. And so in that case, in that instance, the measure is reliable, but it's not valid because it's giving me an incorrect number. So it's consistently wrong. And in research, if something is consistently wrong, it may end up classifying participants incorrectly. And so there's an inherent danger there to your study. If we use an IQ test that gives completely different scores at time 1 from its scores that it gives in time B, It tells me that, is it reliable? No, because it's giving me two different answers at time 1 and time 2. Is it valid? No, because how do I interpret this? I'm getting one score at time 1, one score at time 2. If I repeat this test, is it going to give me different answers? Many researchers would use this word, totally useless, right? Because it's neither reliable nor is it valid, because you cannot interpret any single score in a meaningful way. So this test is useless and we wouldn't use it in any way. On the other hand, if we use a well-validated, so in other words, it's a valid depression scale, it's measuring depression, and we know that once we've put it through internal consistency checks, it's come back with a Cronbach's alpha of 0.92, which is very close to 1, very, very close to 1. Very high Cronbach's alpha, by the way. We know that it is both reliable and it is valid. It's been put through reliability tests and validity tests, and therefore it's a trustworthy measurement, and we can proceed with using the outcomes of that test in our data analytics. Coming on as we approach the end of the second session, common measurement errors creep in. We are not perfect. We look at the world, we interpret things, and we measure things based on different factors. Common errors that creep in are things like response bias. Here are things like where you go out into the field, you survey people, they tend to agree with everything you say. Yes, I agree with that. At university, some 20, 25 years ago, we had a common saying amongst my peers, where we would say, when in doubt, choose C, and we'd always choose C on multiple choice answers. It didn't give us much success. I don't advocate for it, but it's an example of response bias where people choose particular items, particularly within multiple choice question. Human recall is the worst thing. Eyewitnesses are the worst. When we ask people to remember what had happened, participants may not recall this accurately, and that's called recall bias. Item non-response is when people skip questions, when they end surveys too early, when they drop out of longitudinal studies, they only participate in the first, second, or third measure, and they don't participate in later measures or later years of a longer longitudinal study. Or data handling errors. These are errors we make as researchers. Things like typos. We type a 5 instead of a 2 on a keyboard. We click female instead of male if we are categorizing people. We miscode things, or we don't complete data captures. How do we minimize this? Good design can solve for this from the very beginning. To avoid response bias, we can use balanced scales. So where people are inclined to give you the agreeable answer, or to, in our case, select C, we ensure that we reverse code items. In certain items, 1 would mean strongly agree, and in other items, 5 would mean strongly agree. So a respondent simply moving down a list and selecting all the 5s, it would become quite apparent in your data cleaning that something like a response bias has crept in here. Certain items like income, gender, race, and other more sensitive issues suffer from something called social desirability. Here, ensuring things like anonymity, asking questions in a more indirect way can minimize the measurement errors that exist with response, with social desirability issues. Interview bias. Interviewers tend to be biased. They want to rush along. Sometimes we pay interviewers by the number of questionnaires that they complete, and they tend to ask questions in a particular way. Instead of saying, how much do you agree with this? They would say, surely you agree with that. Qualitatively a little bit different, but it leads to a bias in our data and a measurement error. So interviewer bias can be avoided through better training, through standardizing your scripts, through standardizing the way in which questions are asked in the field. Recall bias is again related to participants not remembering things accurately, reducing the recall period, waiting maybe a week before you come back to respondents rather than asking them to remember things that happened 6 months ago is very, very difficult, or using more objective records, video, audio, things that were present at the time in question when things were happening. Missing data, maybe use shorter questionnaires, send reminders to participants to complete questionnaires so that we don't have skipped questions, or people ending surveys early, or people withdrawing from longitudinal studies. And then coding errors is just really to ensure that our processes, our governance, our data governance processes is spot on, that we don't miss anything, double entry, data validation, and more effective data cleaning checks will help us to reduce coding errors. And so as we come to the second to last slide, we look here in session 2 at variables and measurement concepts. When we think about what we covered here is that the variable and defining the variable is the most important aspect of qualitative research because it informs all the rest of your analysis. How we define the variable means how we measure it and what we are able to reasonably do with it in our quantitative analytics that follow. Measurement matters, colleagues. If your ruler is crooked, your building is crooked. If you are using, skew lines, you're going to cut skew. And so ensure that you have quality measurement because it determines the quality of your statistical output at the end. And then validity and reliability is critically important. Validity determines the accuracy of your measurement. I don't advocate holding a dartboard while someone is throwing darts at it, but it does determine how often you're going to hit the bullseye. And then reliability, as we've just spoken about, is the consistency with which you measure. In the image, you see that all of these young, beautiful scientists are getting 5 grams out of their measure. They have standardized their measures. And the reliability leads to consistency, and consistency linked to validity makes for better research. And the one key thing, 20 years in this area of research that it has taught me is that design and statistical reliability and validity starts early in the process. Get involved in the beginning. Don't just think I'm a statistician, I only get involved at the end. Good statistics begins long before data analysis in the design phase. I've used an example here of a clock that's mixed with a compass. I call it a time machine because you both need to know where you are, when you are, and where you are going if you are really going to work in statistics. When is the time tells you what we are doing, where tells you where we want to go with this. And so designing for that at the very beginning helps you avoid some of the pitfalls of quantitative analysis that often creeps up at the very end, which could have been better planned for in more reasonable and accurate design. We do have another quiz. You can either scan the QR code on the screen. You could type in, so I'll just ask Zaki to drop the form in the chat. If we do have time, we'll come back and answer some of those questions. But I think we are running a little bit short of time, and so we might not get to the second quiz. Zaki has just dropped it in the chat. Read the paragraph, look at the questions, answer them carefully. I will send your responses in summary form to Zaki. If there is some time, he will talk us through some of that towards the end of the conversation. We have, allowed some time for questions at the end of the next session. Drop them in the chat. Zakir will collect them. I do thank you, colleagues, for making the time, for coming to this session, and for paying attention and for asking some of your valuable questions. I hope it's been good for you. From myself, I hand over now to my colleague Van Dutsai to take you through the second half of our session. Zakir, over to you.
Good morning, colleagues. Zakir, I'm not sure if you want to say something before I proceed. Zakir, should I go ahead, or you want to say something?
I think you should just proceed, Van Dutsai.
Okay. Thank you Saya, for an engaging first part since morning. And thank you, colleagues, for being still with us up to now. Okay, I'm going to talk again, continue with the foundations of quantitative research. And I'm going to focus on the research design, on sampling, and on the questionnaire design. I think we already had, when my colleague was speaking in the morning about research design I think it was his slide on the research process where he talked about the research design being a blueprint for conducting any study. Why is it a critical component of the research process? This is because it allows drawing of meaningful conclusions from research, and also it is the one which allows us to contribute to the body of knowledge in a specific field. For example, I cannot talk about random sampling when we are doing qualitative research as an example, because random sampling is not part of a design under qualitative study. So every field has different designs, and for us to be able to say we used this and we're finding this, then it has to tick the boxes, but not as in just ticking the boxes. I'm sure some of us, we have, for example, submitted to journals or even our studies, whether we did a mini dissertation or a full thesis, but we know we are supposed to follow a specific design when doing a particular research. Hence, it's very critical in the research process. We also need to think about making a well-constructed research design, which is essential to ensure that we meet the research objectives. I've already seen a few questions. For example, if we want to speak about the whole population, what do we need to do? Which design do we need to pick? Because it's not just having a sample and saying this is speaking about South Africa or Africa. It has to meet the necessary, as we'll engage below. Again, Saya has spoken about validity and reliability and generalizability of research findings. Just like the above us bullet point, we cannot generalize about a whole population if we didn't use the design which makes us able to generalize. So in the elements of a research design, it's the one which guides us actually on the questions, research objectives as well as questions. Depending on your particular questions, it guides you to the research design that you can use. It also feeds into the data collection methods that you can use. There was a question in the chat earlier about I think the minimum and maximum number of participants in a qualitative study. So we can also actually think of the design. If I design a qualitative study, if I have 100 respondents, for example, most of the time it won't mean anything increasing the number, because it doesn't add anything other than what I would have gotten maybe from 20 participants. So it all actually is affected by what design I'm using. Sampling, which design and which sampling techniques is guided by that design. Also, the data collection instruments and the data analysis itself, the time frame, for example. If I want, as an example, to see in 2022 how many what proportion of the South African population were males and females. So I'm just looking at 1 year. But if I want to see what has been the pattern of the proportion of males versus females over the past 20 years, then already I can see that the time frame is already changed, because now I'm looking at a time series. And the presentation of the data actually also is influenced by the design. For example, we cannot represent, I think it goes back again to the different data types of variables that, as I spoke about, we cannot find, for example, an average of household size. If we say, you find sometimes information saying that, but number of people in a household is a discrete number. So to say 2.5 children does not really make sense. So we need all this when we are thinking about the design that we are going to use. So quantitative research, I'm just emphasizing or reiterating what my colleague said in the morning earlier, describes and explains phenomena by collecting and analyzing numerical data. So again, you also indicated in the chat earlier that when you hear quantitative, what comes to mind? I think the majority said numbers. So yes, that's what quantitative research does. And the choice of research design depends on the nature of the research as well as the goals of the study. So we don't just find ourselves using any design, but it depends on what we want to achieve through the research that we are conducting. The two main groups, of course, there are many ways of categorizing the designs, but the two main categories that are normally used is experimental and non-experimental. So with experimental, there is cause and effect. Data is analyzed to test causality. This is caused by this, or this is an outcome of this, and we actually have to attribute. So experimental has to do with attribution. If education leads to finding employment, then we have to actually attribute that it was the education that caused that. And with experimental, we talk about control involves manipulation of a variable and or groups to isolate the causal effects. And then we have the non-experimental, which include observation. For example, we can be just observing data without manipulating or controlling it. We also have descriptive. Saya is also talked about that. Where he did refer to research design partially when he talked about descriptive statistics. So that's actually a research design. We're just describing traits. For example, on average, people from Mozambique have this level of education. It's just describing. We're not doing anything. We're just giving what is showing what is the data giving us. And we also have correlational and non-experimental, which is talking about the association between variables. The example that was given in our exercises earlier, in our exercise earlier, where we are saying what is the effect, not effect, but is sleep, number of hours of sleep in any way linked to scores of students or to stress levels. I think, as I have said in the morning, I want to reiterate that this module is not going to cover everything about quantitative research. It is only laying out the foundation, but I think there are some critical questions that might need to be addressed. For example, there was a question, I think it came more than once. I'm not sure if I don't remember if it was from the same person or different people, of the confounder variable. So in our example that we already used, a confounder variable affects both the dependent variable and the independent variable. So in this case, if we say number of hours of sleep influence the performance of a person, exam scores, we have stress, which actually is linked to both the dependent and the independent variable, because stress actually can affect the number of hours that a person sleeps. And at the same time, stress alone, even without looking about the number of hours a person sleeps, can also affect the score. So in this case, we have stress as a confounding variable. So that's what it means. And the control variable is normally brought to try and reduce the bias of a confounding variable, so that we can have the link of the independent to the dependent variable without having any bias. For those of us who did, when I went to school, it was called Economics 101, the ceteris paribus, it actually helps us, the control variable, to then say, holding all other factors constant, then this is the effect of number of hours of sleep on exam marks. So that's the link kind of between a control variable and a confounding variable. Okay, I think since morning we have had experimental, we have had correlational, we have had descriptive. I want us to have a short activity here with a few questions, and for us to try and match what is happening with what design. Is it an experimental design? Is it a quasi-experimental? Is it a correlational? Is it descriptive? Zakir, over to you.
Okay, thank you, Vandudzai. Tabu will put the poll up, and then please answer the questions, and then Vandudzai will discuss the correct answers, or the most correct answer, once we have finished completing the questions. Tabu? Okay, so you should have a question on your screen now. How much time do you want to give them to complete them? 5 minutes, Vandudzai? Okay, I think we'll give you until 11.
Yes,
about
yes.
11:42.
Sorry, I forgot I was muted. So does
Okay.
everyone have access, or should I get it and paste the QR code?
It should be on their screens. Can anyone tell us if they're having a challenge seeing the questions? Okay, I see thumbs up.
Oh, okay. So it's, yeah. Okay.
You can also put a QR code if you don't mind, Vandudzai.
Okay, we now have okay, I think people are getting onto it. Okay. Okay, allow me to end this one with about 32% of respondents now. And we go to the next one. Okay, we have, at least we have 50% now saying experimental. So yes, this one is experimental. And yes, we do have experiments in social sciences as well, for those who might not know. So it's experimental, given that it's randomly. So the key word with experimental research design is randomization. It has to be randomly, the participants or the observations have to be randomly selected for it to pass this test of being an experimental research. But we will discuss this further. Can we please go to the next one, Tabo?
So they have been answering all of them, Vandutsa. They've all
Can you come
come up with the
again?
same. They've been answering all of them.
Oh, is it? How do I move now?
Can you not scroll down to the second question?
Oh, okay. Okay, so the first one was experimental. The second one, because the researcher now, we take the researcher's control of assigning. So the students choose for themselves, but we have an element of experimental research still in it, but because the researcher, him or herself, has lost control. So it's no longer a pure experimental research, and we again have the majority saying it's quasi-experimental. Yes, it is quasi-experimental. It will fit under experimental, but not 100%, but we have certain techniques that we have to do to still analyze the data under experimental research. That's correct. Thank you.
I just want to check, Tabo, how do we share the results on the screen? They're saying they can't see anything. Okay, can you see them now? I see some people say there's nothing on screen. Can everyone see it?
Okay, now we can see. Okay.
Okay, you can go ahead, Windows.
Okay, so there was a repetition there of the other question. So we go to the one in 2023, provincial government rolls out a school feeding program, but only in districts where more than 60% are below the poverty line. The question is to compare learner attendance before and after 2023 in districts versus similar non-selected districts. So again, here we want to see the intervention. So the intervention is the school feeding program. So also, besides the randomization, remember, for it to be an experimental or quasi-experimental, there has to be an intervention, which now we say it is because of this intervention that we got this outcome. So in this case, which comes out as number 4, but it's supposed to be number 3 because of the repetition, then we again have a quasi-experimental like before. Okay, we go back to the screen time. We had this earlier. In the case of our activity from SAIA, but here it's actually adults, not students. So we are investigating daily screen time with average sleep hours to understand whether people who report more screen time tend to report less. So tend to report less sleep hours. So in this one, yes, again, the majority is it right. It's just the link. What is the link between the time we spend on our screens and sleep time? It's correlational. Yeah, so that was the exercise, and thank you for participating.
Okay, I've just put them in the chat as well because some people were experiencing a problem. But you can go ahead with the presentation, Windows.
Okay, so yes, as I said, and as Saya has explained, so descriptives, it wasn't there among those options, but in the question I did say choose between the 4. It was just to, to give us a little bit extra for us to see exactly what is it. So descriptives is just to say what it is. For example, again, in our poll on the Google form, to say how many are from where, 20% or whatever are from Southern Africa, 80%, I forgot the actual figures, are from South Africa, and maybe I've already 100, which is wrong with numbers. Okay, let's say 70% from South Africa, 20% from SADC, and 10% from the rest of the world, something like that. It's just giving us that. It doesn't say anything at all. It's just to give the picture of what it is, which is the information we normally find from household surveys, from census data. If we are to go to specific data sets, they just tell us that 60% are below the poverty line, 20% are under the age of 15. So it's just that's what descriptives which we didn't cover in this exercise talks about. So when we are doing quantitative research, the important question is now, which design now should I use for my research? Sorry. So we choose our research design guided, again, as I said, by the purpose of our research. If we want to see, I'll go back to the examples. If we want to see the impact of a school feeding program, if we want to see the impact of students from low-income households getting scholarships, then we have to do an intervention that's experimental. So if we want to see the impact of something or of an intervention, we know we go experimental, either the experimental 100% or pure or the quasi-experimental. And to describe or identify trends without identifying causal effects, for example, a non-experimental design, what is important is that the sample should be representative of the group for which for the answer that we are seeking. We will talk about that when we talk about sampling. And we also note that as we collect data, usually we experience challenges with collecting data from the same units over time. So again, we might want to measure trends over time. There are many examples of that, or even with the experimental one, you want to see the intervention over a number of years. Some people move, for example, if you start with someone staying in Gauteng as an example, maybe they moved jobs or they changed places for one reason or another. So we have those units changing over time, but we have many ways of ensuring that we still have a representative sample even with those changes. We usually replace by people who have relatively similar characteristics, maybe age, education, and family background, and so forth. But of course, we have to know that there are no two Vantu Zaimbandas in this world. It's only me. That's the challenge of experimental research design, especially in social research, socio-economic research, because for it to be completely pure, we need a counterfactual, but we don't have counterfactuals of people, but there are techniques to make sure that it actually meets the requirements to qualify as an experimental research. And also because we need to identify the effect, as I said, of the intervention. An experimental or quasi-experimental design is the correct one. However, a pure experimental design would be best, as I said, but we also need to think of ethical considerations and costs and complexity of administering the experiment. One example is putting people under a treatment medically. Can we really want to achieve an experimental research design by denying others who actually need the treatment because we want to have a pure experimental research? Another example is a poverty one. Do we select people into the experiment and into the control group, so the control group is not getting the intervention so that we are able to compare? But for ethical reasons, usually we don't do that in social sciences research because it's not morally correct. So we go most of the time to quasi-experimental because we now look for people that are, at the margin of entering into a program because their characteristics are almost the same. Then we have quite a number of techniques, for example, differences for us to track now and attribute impact, but pure experimental for ethics reasons, in most cases, is not ideal in social science research. Okay, then we move to sampling in quantitative research, which again has been partially covered by Saia. Okay. So in terms of sampling techniques that are used in quantitative research, we have probability and non-probability sampling. So the probability is the randomization that we talked about, which helps us to talk about the whole population from the findings of the sample. Quantitative research often focuses on being able to generalize about the larger group or the population than the focus on the sample itself. And it tends to rely on probability sampling techniques. However, there are also many instances when non-probability samples are important or are maybe the only option where we do exploratory research or evaluation research. There is someone who asked about when we don't know the population, then what do we do? Do we stop doing research because we don't know the population? No, we actually do, because we are actually, covering a gap, or not even a gap. We are providing evidence where there was none. The example that was given was for informal traders. What do we do if I want to do a representative sample? We won't go the probability sampling way. We have to do exploratory research because it's us who are starting it. It has not been done. We can still go and study it, but the key thing is when we are analyzing and interpreting the results. So we will not say now we will not speak to the findings as if they are about informal traders in Southern Africa, if the study is focusing on Southern Africa. We will say now, we'll talk about the findings, saying the findings on the sample that we collected, we are no longer taking of informal traders across Southern Africa, but we are not saying informal traders in Southern Africa are like this as we would when we have a probability sample. So that's the only key difference. We can't attribute to the whole population. We can only make inferences about the sample or the data that we collected. That's what is important. Why we do that? Because with probability sample, the sample resembles the population from which it is drawn in all aspects important for the research being conducted. That's why we say the South African population is ABC when we're only talking about, when our data is only a sample, a subset of that population, but because it would have met all the requirements for us to talk about the population. Why do we say that? Because we would have used probability sampling where all elements in the target population have an equal chance of being selected for inclusion in a study. That is random selection. Hence, we are talking about the whole population because anyone could have, if it's people, anyone could have been selected into the sample. So that's why we are talking about it, because of the randomization element to it. One important aspect to remember with sampling is that we have the population, which is the group to draw conclusions about, and we have the sample, which is the specific group of individuals to collect data from. But there is also the one in between them, which is the sampling frame. That is the practical device, if we can call it that, to reach the population. So in most cases, we won't be able to have, for us to do a random selection, for example, we won't have every element of the population in our spreadsheet or whatever, because it's not practical. But we have a list actually that we can collect, or a register or a map of units from which the sample will be drawn. So the random selection will be a subject. It's the sampling frame to which we subject the random selection, not the population itself, because normally we don't have all the information of all the elements of what we want to study. So it's always important to remember the sampling frame. One example of a study that we conducted is on the activities of civil society organizations in South Africa in providing food to poor communities, because it's not every CSO, civil society organization, that is dealing with food that is registered in the country. So what do? We go to the Department of Social Development, which is the register for the civil society organizations. And from that, we make a list. Some have deregistered, some have not deregistered, but they are no longer operating. So for us to do like a robust exercise, we had to verify which ones are still, among those in the register, which ones are still operating. We confirm, and then from that we draw the sample. But we talk about civil society organizations focusing on provision of food in the country, even though there is no way we can get each and every one of them, because not all of them are registered, just as a practical example. Okay, so just to emphasize again, so from the population, we want the sample, but we have to work with the sampling frame. That is where the sampling frame is what you can number now, 1 to 1,000, whatever your numbers are, and then you subject it to a random selection of the sample. Okay, the sampling methods that we normally use is the simple random sample, which is what we've been talking about. So we used to have long ago, I'll keep on referring to you for those of you who might not know, maybe who were born as I was doing my undergrad. We used to have some documents with the random number. So you would take that and then pick it will randomly assign the numbers. So that's what we would use. But now many software, the easiest one being Excel, it is a random number generator. So let's say your sampling frame is 1,000 units. Then they are numbered 1 to 1,000. Then you do your random number generator, and then every number that is selected, that's the one that you select, you put into the that's your sample. That's where you collect data from. Okay. Maybe in the chat, can we quickly I want to be able to see what is happening, but I can't.
Do you mean you can't see the chat?
Yes, I can't see the chat. Okay.
No, maybe I'll let you know. I'll tell them what you want and I'll read out responses to you.
Okay.
Again.
Okay. I wanted us to quickly indicate if the simple random sample is the best. If not, why?
Okay, I'm waiting for responses.
I think there was a question again earlier about
So Marcel is saying bias.
Okay, bias. There was a question earlier, I don't remember. Everyone has an equal chance to be selected, so simple random is best. Okay. It is not the best due to biasness. Okay. Okay. I don't remember the question, but it's related to this biasness. Thank you, colleagues, for the responses. It may underrepresent. Yes. So let's say we want to study about Southern African countries or SADC countries. Do you think it's not possible that all the random numbers will go to units that are all from Zambia? For example, we want to study about informal traders involved in food selling from across the SADC region. With the random number generator, is it not possible that all the selected ones from the random selection will fall only in Zambia? So yes, it may not represent all the population. That's very true. And for that reason, that's why we have other variations of random selection. For example, the systematic sample, if we have numbered, then we say every nth unit is what we select. So we are sure that we are not selecting, of course, depending on how our register, orders the units. But at least it assures us that we are not going to select just from one corner or the numbers 1 to 100, for example. If we want to select 100, a sample of 100 from the 1,000. So the systematic is the first option. But we also have a stratified one where we have, for each country in the SADC region, we have a strata for Zambia, we have a strata for Mozambique, for South Africa, for Zimbabwe, for Botswana, and so forth and so on. And we select a random sample from each of the strata. Therefore, we are assured that from each SADC country, we do have representatives in our sample. Then we also have a cluster sampling, where this one works more. For example, if we have, say, districts in the same province, or for example, district maybe is too large. What are the other enumeration categories? Maybe a village. Okay, if we're in the rural, maybe a village in a certain district. So we have clusters as villages. So now we do random selection of villages. So with cluster sampling now, if we select a village, we are going to include into the sample all the elements in that cluster. But still, it's kind of representative because we would have done random selection of the villages. To be even more robust, we could number our villages, and then we do systematic sampling of the villages. With maybe every 10th village, if there are 50, something like that, every 10th village, we select it into the sample, but all the elements in that particular village will be into our sample. So these are the main methods that we use in sampling, and to try and remove or reduce the biasness of the simple random sampling. Okay. So we already have the weakness of the simple random sampling. Maybe can we have 5 or 6, 10 people indicating what could be the weaknesses of the systematic, of stratified, and cluster? We have already talked about their strengths. What could be their weaknesses?
So we have a question. So Pelela says, sorry, Doc, but isn't that stratified sampling? I don't know what that's in reference to.
Which one?
Can
Pelela,
you come
which
in
one?
on the chat? Okay, while we're waiting for Pelele, Clement is
Okay,
asking, so I ask again what determines okay, are you unmuted? Okay, you can come in, Pelele.
Yes. Hello. Sorry, excuse me. Sorry to butt in. Was responding to the simply random sampling is often considered one of the best sampling techniques because it gives every member of the population an equal chance of selection, thereby minimizing bias, enhancing the representativeness of the sample. I was a bit confused. My apologies. I was asking, in that description, doesn't that describe stratified random sampling? My apologies.
No, okay. No, it's the simple one, because in principle everyone has a chance, but it doesn't mean it has the spread across all elements in the sampling frame as I have been explaining. Okay, I can now see the charts as Akiri saw. The claimant says, so I ask again, what determines the population, scope, research aims, or any other? So what determines the population is what is there. For example, if we want to research the example that I gave of the screen time and the number of hours people sleep among adults. So if it's in a country, if it's in South Africa, then the population is the South African adult population. That's what the population. Probably what you want to say is what determines the sampling frame, probably because the population, no one has control over it. Even the research aim doesn't control the population. The number of goats in South Africa, for example, or the number of maize farmers in the SADC region, that's the number. It's not the scope or anything that determines it or controls it, but that's what is there. If I make it clear again, the study, the exercise that Saya led earlier in the morning, the number of students at a Western Cape Public University, that's the number that is there. It's neither the research aim or anything that determines it, but that's the population. So yeah, it's your question actually that I'm not sure how to.
Yeah, that's true. I agree with
Yes.
you. I agree with you totally.
Okay.
Yeah,
Okay.
I agree. Well, maybe I was wondering, maybe from the framing of the title, as the researcher is going ahead with the study, is already bearing in mind what the population is going to be, or I don't know, is the population that will determine what the title will be? That is the difficulty that I had there in trying
Okay.
to.
So maybe just to quickly come back again, it's your research now which will guide you to the population that you want to. For example, if you want to study about gender violence, for example, then you should be directed to people who are married. That's your population. If you want to study about impact of screen time and exams, either you go to primary level or high school or tertiary, something like that. If you want to see about effectiveness of, what is it called, continuous education or skills development for teachers, then your population definitely is the teachers in the country. If you can now reduce it to say teachers in public schools or teachers in private schools, but it's the question that guides you to the population that you focus on, but the population itself is not affected by anything. Okay, so do we have any on the weaknesses of systematic, stratified, or cluster sampling? No. So maybe we agree there are no weaknesses. They actually address the weaknesses of the simple random sampling, probably. Okay. in the interest of time, my time is again running out. Okay. So we go to designing of a questionnaire or data collection instrument for quantitative research. So the questionnaire is the widely used data collection instrument. What is important for us is we don't just throw questions. Actually, a questionnaire has to have aims. What is the aim of your questionnaire? And depending on the aims, again, that is what will guide you in terms of selecting the style of the questions, designing the questions themselves, and structuring the questionnaire. Also, now we are moving to the steps. After you design, you structure your questionnaire. For example, you can have modules that focus on household dynamics, for example, or on demographic information. Is exactly what our questionnaire in the morning did. It asked us if our age, our what gender, where we are from. So though usually that module in the small team that I work with, we usually put that module either at the beginning or at the end, depending on how long our questionnaire is, because sometimes it's best to put it at the end. People are tired, and then you just ask them about their age group and something like that, because that one is not taxing. Okay, we pilot our questionnaire, we revise, and we administer the questionnaire. Basically, that's the procedure. So we don't really have to invent the wheel as others always sing. We can use or get from literature in terms of the concepts that others have already done, if it's related to our study. However, usually trying to follow another person's questionnaire sometimes can throw you off, because you end up in most cases putting questions that are not related to your study. So it's better to get it as a guidance, but not to really use it as the template for your own questionnaire. And then how a questionnaire is administered affects the research design. For example, I think we saw in the morning that not everyone answers. So already we can see that the administration affects even the responses that we get. And online, I think, as we might know, it's not the best in terms of getting the most responses. When we are designing a questionnaire, think about the order and flow of your questions. It's very important to think about the flow. It has to flow. Also helps the person think through when they're answering. And most importantly, keep it as short as possible, but getting as much as you can. So things about filtering or branching, for example, if it doesn't apply to a certain person, do the skipping patterns to make it as short as possible. So what types of questions do we use in quantitative research? We have both open-ended and closed-ended, but respondents are more likely to skip open-ended questions. For example, how much do you earn? Not many people are willing to give. Or how old are you? We know, especially they say ladies don't want with their age. So what do? We normally use the range. 10 to 20 years, 1,000 to 5,000 in terms of how much you earn. And again, going back to the variables that Saya talked about, we can also use rating scales, but we need to have the practical number of point scales. Do we use 3? Do we use 5? Do we use 10 to say, are you still okay with this module? Yes, very much, slightly. Sometimes, you know, it doesn't mean anything. So depending on what you are measuring, then you can put them 3 or 5, or yeah, usually we work with between 3 and 5, but it really depends on what you are measuring. And importantly, the scales must not be ambiguous. There is a link between scale and categories, for example. it's best not to work with categories personally for me, but with rating scales, because we can aggregate rating scales into categories. But once you ask categories, you can't unpack them, you can't disaggregate them. So rather work with scales as much as possible. If you want fewer, or if you want just 2, then you can aggregate them together. Okay, the ideal question must accomplish 3 goals. It has to measure the underlying concept it is intended to. It must not measure other concepts. For example, if you're asking a question about income level, just leave it to income level. It should mean the same thing to all respondents, because when we eventually analyzing, it's not like qualitative analysis where now we use thematic. With quantitative, it has to be the same. Then we can say on average, it's like this, because it meant the same for everyone. So as much as possible, if there is diversity in the country and you need to translate, make sure you get translators to ensure that you get the same responses. Keep sentences short and simple, avoid vague language, avoid technical language and jargon. Last point in this slide, anticipate all options, allow other, please specify. I think you saw with our questionnaire in the morning, it's only limited to certain regions and or countries, but we had someone from Abu Dhabi and we didn't think it through, and it actually happens every time people design a questionnaire. Rather put other, specify, so that you cover everything. Okay. These days, actually, I think maybe with the AI, we can get this information. We have many online tools that we use to collect data. We have to think about ethical considerations, and we really usually favor those that are easy to find, accessible and reusable, and also cheap. I will not go much into this because of time limitation. Zakir, I'm not sure if it's still possible for us to do this. Maybe you give me 10 minutes from your time, then we do it for 20 minutes.
So what I'm going to do when it says, I'm going to add what I've done is I've added some questions related to AI. So I think let's give them more time.
Okay.
So we're going to give them 25 minutes. That will take us to about 12.
Perfect.
And then we'll take 10 minutes for discussion. And then if you will allow me to maybe just go 5 to 10 minutes over to close out the session, because I think it is important that we do these activities properly.
Perfect.
So Thabo, I'm going to send you the questions, and we're going to have 25 minutes and a maximum of 8 people in a group. Is that fine,
Okay.
Thabo?
Yes, it's fine. Thank you.
Thank you.
Okay, so colleagues, when you go to the breakaway sessions, please, as soon as you are 7, 8, start the discussion, because we don't have time. But I think the questions are very important to just, put everything together that we have talked about since morning. Thank you.
Can I break now? Yes, but I only sent you the questions now, right? So, but you should get it now.
Hi guys.
Hello. Hello, Toseleto.
Hi, how can we get the questions to discuss?
Um, I think they are still sharing. Just wait.
Oh, okay.
Mm.
Hello, are there any discussions going on?
Would you like to lead the discussions, Marshall?
I just joined in now and I'm not even familiar with what the government institutions
Let's see.
are. Sorry, I was on another call.
We have the questions now on the chat, I think.
Yes.
Thanks, Pelela. Guys, how do we want to approach this?
Can we go for like an experimental design? Or correlational between the two? I don't know.
I know we're short on time, but I was thinking maybe we could introduce our research topics and maybe find a common factor and start from there. Because, like, what is the starting point? Did we not have a prompt?
Maybe we could just start on something that is common, and then we can just work around that. Because I think if we are taking or if we are introducing our own research, then we won't have like a balance as to what we can compile as one research for this activity. So maybe something that is common, we could talk about maybe abuse, maybe the upcoming elections, or maybe just inequality or poverty.
I would go for the question of elections.
Okay, do we all agree on elections?
I'm fine with that as a topic.
Yes, I do agree with the elections.
All right, so then we are also going to need one person who is going to take notes for us as we come up with suggestions and ideas around the elections topic. Who would like to make some notes? Okay.
Well,
So
I will not take notes, but I'm trying to lead the discussion. Maybe the first question becomes: are the youth or young people justified for ignoring elections?
Okay, so I will do notes, okay, and I'll just try and summarize what everyone is adding. And if anyone else wants to make notes as well, they are welcome. So let's have you, Liseja, lead the discussion so that we can complete the activity before 1.
Yeah, my first question is that are they justified, these young people, for just ignoring elections?
Can you please
If
repeat
that
that?
question is perfectly structured, because we are now told that we need to raise proper questions for proper answers. And maybe anybody can add to the question if it's not properly structured.
Can you please repeat the question?
My question is, are young people justified? Are there grounds for them to believe that there's no reason for them to get involved in the elections?
Oh, okay, I get you. I'm just trying to think what type of
Yeah, maybe my question is not well structured, but somebody could just structure it in a way that it becomes, as taught by Professor Parker, we have the right answers. Or put differently, is there a correlation between age and voter apathy?
Yeah, I think that option is better because now we are looking at like two things. We are comparing the two.
Is there a correlation between voter apathy and age?
Then our research question can actually be what is the correlation between what age and
voter apathy.
Yes.
Okay.
Colleagues, what is our problem?
All right. Remember, we said that we want to base our research around elections. So now the next step that we need to do would be to decide what type of research design we would use. Are we going to use a descriptive research design in terms of coming up with the research question? Are we going to use a correlation research design? So that is the discussion that we should be having to complete the first activity.
Okay.
Well, once we, I mean, I'm not a statistician by any chance, but once we do correlation or is it comparison of two variables, what is it called? That is your
correlation
what normally,
research design, yes.
Okay.
I think first, we need to establish what around voting, what exactly is the problem around it. Then from there we'll be able to come up with our research question, and then from the research question, I think it will also guide us on the design. Because if we don't know the problem or what exactly we might want to look at in this area of voting, then it will be difficult, even the design, So I think we can think a little bit about.
I was thinking that the problem would be voter apathy. We do know that as a problem, young people generally don't vote. That is called voter apathy among the young people.
Correct. That's our problem.
I don't know what I mean by young, but yeah, if
So I think we are sorted with our problem. We have the problem.
Okay.
So, sorry, what would we be measuring then with voter apathy?
So I
we
think
were trying to check whether, are young people, what am I thinking? What are we measuring?
You can actually check this problem in a different population.
Okay.
In just to see the difference, maybe something like that.
we could also look at factors affecting the cause of voter apathy.
I can hear.
Factors causing it, right?
Can you repeat that, Kashima?
Can you hear me?
Yes.
So what I said is we could study the factors influencing the voter apathy by younger, because there's something causing it, right? So we can investigate. They can be 5, they can be 10, and whatnot.
Oh, okay.
Yeah.
What are the causes of the voter apathy among young people?
Yeah.
Okay. All right. So maybe instead of saying causes, we can use barriers. Barriers influencing voter apathy among the youth of South Africa.
We could also say We can also call it factors determining or influencing voter. So they are factors, right?
Okay.
Yeah.
Okay. All right.
Okay.
And the research question would be?
Would it not be like answering what are the actual factors?
What are those factors?
Yes.
Okay, so we do have a possible question in the chat.
But is the
And
question, sorry, colleagues, is the
yeah.
question, what are the factors, a qual question, or is it the quantitative question? Is it the qualitative question? I don't know. Like I say, I'm not a statistician by any account.
It can also be quantitative, where you have to how do I put this?
Okay, let me help you basically, right? So if it's a
Please do.
qualitative stuff, you could code it in the instruments, right? And you could use tally to be able to know the number of people that said, for instance,
Okay.
All political will, right, is a factor why they don't vote, right? So if you have 90% of your respondents say that is the reason why they don't vote, right?
Mm-hmm.
Even though it has a qualitative narrative, right? The analysis was quantitative because you show the distribution as to the percentage of your population that said poor political will is the factor. I don't know whether you understand what I'm saying.
Yes, I do. I'm following.
All right.
Okay,
Okay,
then
for me, I think the question actually it's more leaning to qualitative because of we do not know the factors. But if we knew what is exactly the factor would say, what does this factor to be let's say specific? What does X factor affect the voting apathy? Then we know now we're working into two relationships. But for now, we don't know the factors. I think it's more of qualitative because we want to know what are those factors.
Sorry to jump in. I agree with Dineo. Are we looking for the actual main factors that are contributing to voter empathy among the youth of South Africa? Also, are we going to be able to describe what we mean by youth? Is it people who are qualified voters at a certain age? Are we looking at social, economic, or political factors that influence voter empathy? Or are we looking at, I don't know,
Recording in
maybe
progress.
the roles? What role, for instance, like access? Are we looking at factors of access? What exactly are we looking for? Because we need to come up with something that is going to be measurable. Hence, we needed to be able to separate what variables, what are we looking for exactly? So are we looking for all the factors, or we know the factors? We're going to hypothesize and say we know what kind of factors they are facing, or we're looking for specific? Are we going have specific questions? Because in our questionnaire as well, we're going to have to be specific with our questions. That's all I just wanted to ask.
Yes, and in addition, maybe if we pick up one, we would be saying, and I'm just guessing, is the long queues or are long queues the barriers for youth to vote, or something like that? I don't know. Just pick up one and let's move.
Just to come in, factors is a very broad term, so we can look at many factors because we are expected to come up with 6 questions, and I think every question can be pointing to a factor. And also at this point, since we are just dealing with quantitative lessons, I think our the design and the questionnaire should be quanti. We cannot talk, I don't think it will be okay to talk about quali at this stage because we'll be looking at quali, I think, lessons tomorrow according to the program. So I think today we must just focus on our questionnaire will be quanti and everything design should be quanti because quali, let's assume we don't have the knowledge yet
We don't know
because we
about
haven't
yes, correct.
received the lessons.
Okay. How do you move?
All right. The second part of the first instruction that we should look at would be to indicate if we will make use of primary or secondary data, right? So we've already discussed the type of research design that we would use. We already have factors that affect civic participation among the youth of South Africa. So now this one is, I would think, would be a quick discussion because it's just to discuss if we will make use of primary and secondary data. And then we have to move into the questions because we literally have a minute left.
Primary. I vote primary data.
Okay.
Yes.
Okay, let's
Okay.
go ahead.
All right, so primary data, and now we need 6 questions. So I was thinking that we could have a look at structural and agency factors, maybe 3 questions that involve structural factors and 3 questions that involve agency factors. So when we talk about structural factors, we talk about political institution, unemployment, education, and media, right? And I think we have those factors on the list. So maybe one question about political institutions, one question about media environment, one question about education levels or service delivery. Those would be the structural factors questions. And then we need to have a look at agency factors. So agency factors would be political interest. Are they interested in politics? Or personal values or sense of civic duty? Do they feel like their votes matter? And individual experiences, what experience do they have, when it comes to politics in their own environments? Then maybe we can just wrap it up in that sense, since we don't
Please
have
lead us
time.
with one auspicious. You see.
Sorry?
I'm saying lead us with one question there, please.
Okay. So when it comes to structural factors, in terms of corruption,
Okay, I think we're all coming back to the main room. Let's just wait. I'm not sure if everyone is here. There should be more. We had closer to 200 going in, unless the activity scared some people off. Okay, let's just give it a minute to see if we're all in the room again.
Recording in progress.
Apparently some people were not assigned to room. Sorry about that. But I hope you've had time to think about the questions and reflect on it, even if you weren't in a group. Yeah, yes, Belela. I know how it goes with these breakaway groups. You can barely get past the first question. But I hope it was a useful exercise just to start thinking about these sort of things. We can never do justice to this in the limited time that we have. And maybe I'll just invite anyone to come in with any reflections, either about this group or about the session as a whole. We're getting close to 1 o'clock. So I'd like to just open up, yeah, anyone to come in with any reflections for the session or for the whole module as a whole.
Lisija, yeah, if I may, well,
Yes, you can come in.
I personally enjoyed the discussion, and it is so heartwarming to see that one understands these concepts as colleagues verify and validate you once thought. I've enjoyed it. Thank you.
Thank you so much. Anyone else, please feel free to put your hand up. Yes, Leila.
Yes, I want to comment. I'm sure it's for me. I think the breakout rooms are good. We come and discuss, but I'm also facing a challenge that I also faced in the first the chat room that we went earlier. Earlier, I think it was Monday also. So sometimes in the group, people may be assigned, but we find that the participation is low. I remember in the first group, we were only 2 that were talking, and today we're around 20 in the group, but only 4 or 5 participated. So sometimes it makes it very difficult if you can actually be quiet the whole time and not helpful. So it was time sometimes.
So maybe Leila, can I maybe ask you as a participant, what do you think would help to increase participation in these groups? Because obviously we do encourage and would like for people to participate, but this does happen, unfortunately.
Maybe smaller groups, or maybe, I don't know if it's possible to inquire with isn't we have the chat where we can actually even check whether people are really are actually paying attention. So maybe before the final decision is made to send people to chat, check who's really like practically available. Then that way we will know whether it's gonna help.
Okay, thank you. I see smaller groups. I do think that may help, but I'd like your views as well. But I had hands up. Was it Anna? And I see there were 2 other hands that were up.
Yes, can you hear me?
Yes, Anna, you can come in.
Okay. Yeah, just want to give my experience. Yeah, no, it was a good opportunity to break out in groups and to discuss possibly like what we could have done if we were to conduct actual research study. So I am just kind of visualizing how it would have happened in real life if I was going to now transition from a research proposal into now actual data collection. And I can already see that, research sometimes it comes off as if you understand when you are reading everything, and then it's time to implement, and you are kind of caught off guard. Now we were there discussing, so what type of a study design, and then one is having this idea, one is having that idea, and then we are going from, okay, what is the problem, what is the research, so it becomes like really confusing now to choose what is what. So I think it was really a good experience, and I'm just like, this is what it mimics what you would experience in real life. Thank you.
It's so funny. Sometimes you think you have it all figured out. You think you have a simple research question, and then you start thinking about all these aspects and things, you realize how many things you actually need to take into account. Yeah, and I hope that this exercise, I hope it didn't scare you, but I hope it just like opened your eyes, or maybe you already work in this type of work and you know about it. But yeah, there are things, little things can trip you up. I'm gonna take another comment. I'm gonna go from the hands I see on my screen in the order. I've got Claire. Can you come in, Claire C?
I think it's okay. The breakaways were really helpful, and okay, for us, participation was fair enough because people were posting their responses in the chat. But what I realized is with these breakaway sessions, even from yesterday, the time is really limited. We couldn't even go to, I think, number 4. We didn't do that because we didn't have time and we had to rush through everything, but it was really beneficial because we're able to apply what you guys presented since morning. So it was really a good, yeah.
Please also share this feedback. I've shared the form in the chat. It will be very helpful for us when we see all these comments about the breakaway session, how you do value them, but you wish you had more time, or you wish people would participate more. And then we'll strategize about it and think about how we can come back better next year. I'm going to go to a comment then from Ismail.
Yes, thank you. I think I do agree with the previous two speakers, because definitely this was an eye-opener. Quite a few things that we thought we understood until when we discussed, then we get to realize now when we go in depth with them that indeed it's not what it was. But what I also valued, again, in addition to what they've already said, it's teamwork, because we come from different walks of life. We also have different approaches to similar situations. So just getting to share that, I think that's something that is much more valuable, especially in research. But it was quite beneficial. Thank you.
I think that is an important point, Ishmael, and I think different perspectives are very important, even in designing your research. We also talk about engaged research, and even not just doing the research as the researcher yourself. Who are the research participants? How do they view the research and the research questions? All things to keep in our mind as well, even as we design this. It's not even just about us in the room as the researchers, right? As the people who we'll be collecting data from, we also need to know how they feel about this and how they interpret the questions we ask, for example. But I'll go to another comment from Colin now.
Thank you. Good afternoon, everybody. My comment is just in terms of the breakaway rooms. One of the challenges when a group comes together and there's no designated leader, it's kind of makes you have a couple of speed bumps. We're lucky Esther took leadership in our group, but in discussing the topic, the time factor is a huge one, because not just deciding the topic, but also the phrasing of the topic, the way it's worded. Ours could lend itself to both directions, qualitative or quantitative. And my chestnut group was, when it comes to the topic, you first need to sort out the topic before you actually decide the direction of the research. And ours could go both ways. But the big one was specifically just the leadership in the group. And yes, the contribution, I think it was a designated leader, we know, but thank you to Esther that took over leadership in our group.
Okay, thank you, Colin. That's well noted. I think maybe what could help is we share maybe these before, right? And maybe you guys don't just get into a breakaway room and see things for the first time. And then maybe even assign people before, but that's a bit more difficult because we're not always sure who's going to participate and how many people will. But if we could do that, it would definitely help. I'll take a comment from Tebogo now.
Hi. Thank you so much. I think for me, in terms of the breakaways, I think they could be facilitated better as well, because also I think we're from different disciplines. I think the time allocated as well, I think it could be a bit expanded. And then I think also in terms of clarity amongst ourselves, especially in the breakaways, because I think, it could be, I don't know, I think where people are just, we're from different disciplines. So I think better facilitation. So let's get to know each other. I think that moment, and then, yes, let's get into what the topic of the day, or just whatever.
I think what I hear a lot is that a lot more time could help with a lot of this, and giving us more time to know each other and more time to engage with the material. Yeah, but let's see what we can do about that. Please do put your honest feedback into the forms. Before I close up, I would just like to now invite some specific reflections about the module as a whole, not necessarily just about the breakaway. If I could get 2 or 3 reflections or comments. Did you find it useful? Yeah, anything you'd like to share about the session? Anyone? Any final words then from our presenters? Sire, do you want to come in and just say something?
Sure, thanks, Zakir, and thanks to everyone for attending. We started off with just over 200, and we are ending with 140. And as far as my experience goes, that's quite a good retention rate. The one thing to remember, colleagues, is that we're not going to learn everything in a 3-hour session. It is a wide, broad, intricate field. Your specific questions will demand specific statistical quantitative solutions. And so if you didn't get what you wanted from today's session, there are experts within your universities, there are experts within area of expertise, and there are people on this session and on this panel that will be happy to assist you. So there's a solution, a statistical solution to every problem you could think of. And do not be, one of the things that came up in the group that I was in is that a lot of people said, oh, I don't think my answer is good enough. It's always good enough if you make it good enough. So it's about confidence, colleagues. Have the confidence to believe in the question that you're posing, and the technical skills around quantitative research is just there to support that. If you don't know the answer, that's the best place to start, because it means you have some form of curiosity about what you are hoping to achieve. So all the best for all the students, to all the people that are engaging in academic studies or that's going to use some of these skills into the future. And for those that are uncertain, get in touch with us and we'll be happy to help you in driving some of that forward. Thanks, Zakir.
Okay, and then just before closing out, Vandutsa, any closing comments from your side?
Nothing much to add. I just enjoyed. I was floating. I was moving across the rooms. What colleagues have commented about. Some were quiet, some were very active. So it just shows how diverse we are. But great teamwork in most of the groups. So thank you, colleagues, for engaging. Actually, it was a very active session. I mean, I've been on this module since 2022. And I can say, I think this was the most active ever since I started on the module. Thank you.
Okay, thank you so much. With that, I think I'll close us out. I'm just going to say thank you to Thabo and IT and everyone else as well. Please remain with us for the rest of the day in your chosen session. If you want to get into practical quantitative research topics, we've got a session on Stata and we've got a session on SPSS. Please check your program for the relevant links. If you're interested in quantitative research, I know we also have a session on using secondary data. We didn't focus so much on that today. We spoke more about data collection and thinking about our data. But please check the program. I think it's tomorrow, a session on secondary data in the afternoon as well. And then we didn't get as much into the AI as we would have liked. We ran out of time. But I hope you got a taste about thinking about, whether AI can be used in quantitative research and whether it could add the most value and what we should be wary of. But we also do have a full session on AI on Friday morning. So to get into more of that, please do attend that session. But thank you so much. I'm going to close out the session. Everyone here knows also if you need anything, you can email me and the academic queries at hsrc.ac.za address, and I'll be happy to help. Okay. Thank you, everyone. Have a good rest of your day and the week. Thank you.
Thank you. Bye.
Recording stopped.
Francis is done, really. Oh, shit. You read it. This is Francis. You are in there. It's up.
Today, I'm going to give you a quick example of how to detail the theme in Alabar. I have already started by drawing a section front and top view. The beam is 600 millimeter by 800 millimeter by 3000 millimeter. All my bar styles and dimension styles have been set up. I am on my reinforcement layer. My current scale is 1.
Just talk your way through everything you're doing. That way we got audio that says what we're seeing when we're seeing it. Okay. And I'm going to follow you on the control track. I don't want to interfere. But yeah, that's fine. It takes a little bit to warm it up. I need to have 120 degrees Fahrenheit for the oil temperature before we put the power to it. All right, and tell me what issue we're running on here? Rotex 914, that's the one with the turbo, 115 horsepower for 5 minutes, so I'll start continuing. All right. One of the things, when we are we'll be fairly low operating out here, with the strong wind, I'll have to be mindful of the direction I'm turning, because when I turn downwind, can lose some altitude or airspeed. Okay. Turn upwind will gain some altitude or airspeed. Now, is that because of the disc lifting arrangement? It's no different than for an airplane. When you turn downwind, you lift, until the inertia of the aircraft catches up with the wind mass. You have less wind on the wing or the rotor. So it's exactly the same. Now this is a heavily wing-loaded aircraft, so it's got a lot of inertia compared to the wing, not a feather in the wind. So it takes a little while. If you make, say, a quick 180-degree turn, you're down to very low airspeed when you get turned around 180 if you're turning downwind. Sure, yeah. Okay, I'm doing a mag check. All right, that mag's good. That mag's good. Both fuel pumps on. I've got 2 electric fuel pumps, and I'll take off the both of them. I release the rotor brake. The rotor's able to turn now. Okay, there it goes. And I'm squeezing the indicator to spin it up. Don't start to do it. Bring it back there. When we get to a little over 100 RPM, I'll make the announcement taking to runway. Okay, we're going to roll on the runway. Mount Vernon traffic, start out the airplane 109 Mike Golf, taking active runway 15. Taking a left turn out. Okay, now my rotor speed up to 220. Sure it is. Okay. And full throttle, stick all the way back. The rotor's going to come up to more speed, and the nose will lift up, telling me I'm a wing, I'm ready to fly. There's the nose up. And I lift it off the ground. I'm in ground. I'm going up to 65 miles an hour. There's 65, and I'm trimming it for 65. That's our best flying speed. Yeah, it's funny, it doesn't really feel like that speed. We're about 70 right now. Is that right? It's much slower than that. I'm going to turn out and we're going to go over to that
Good afternoon, everyone, and welcome to the session of the 7th
Recording
Annual
in progress.
Immersion. Yes, thank you for turning on the recording. Welcome, everyone. My name is Huitsi Onemaseko, and I will be chairing the session, which is titled Quantitative Research Using SPSS. Okay, so before we present our presenter, as you have heard, please note that the recording and the please note that the recording is this, or rather the session is being recorded, and that you will be getting the recordings and the presentations a day after, which will be tomorrow. So just a few formalities before we begin. If you have any questions, please feel free to use the chat and we will attend to them at a certain time. Okay, so just to present myself, my name is, I've indicated my name. I'm a researcher at the Human Sciences Research Council, and I'm based in the Public Health, Societies and Belonging Division. I have over 10 years experience in statistical processes and research methodologies. I've had the pleasure of working on a number of large-scale surveys. Before we present Dr. Ronel, I just want to make sure that everyone has been able to download the data set that we're going to be using for this session. Please also open the SPSS software so that it's easier for us as we navigate. All right. So our presenter today is Dr. Ronel Supaul. She is a biostatistician and also a chief research specialist at the same unit, which is the Public Health and Societies and Belonging Division at the HSRC. She has previously worked at the MRC, and she has over 15 years experience in statistical processes and research methodologies. She has studied a master's of statistics at the UKZN and PhD through Maastricht University. Please help me as we welcome Ronel. Thank you, Ronel. You can take over.
Thank you, Huitsi. Good afternoon to everyone, and thank you for having me here at this training today, and welcome everyone. Thank you for being here today. So I know we've got the afternoon session, and that's usually a bit difficult coming back from lunch, so you might need to, I hope you already fueled up on some coffee, and we're going to get right into it. So just to note that this is going to be a hands-on demonstration, so you're going to have SPSS downloaded and obviously to open the data set. So I see Sarah has placed the data set in the chat. Please click on the link below now so we can get ahead of ourselves and download the data set. I'll give you a minute or two to do that if you haven't already, and put it into a folder that's easily accessible, and then go and double click on that link. So I will show you what it would look like now. All right, so in my SPSS, where I've put everything in the chat, where I put the data set, that is, I'm going to double click on this data set called training.sav. So all SPSS files end with .sav. And if I double click on that, it's going to open something that looks like this. And I'm hoping I can see a lot of thumbs up from you once you've gotten to this point. And then we will just start by a little icebreaker and some polls with you. So if I can just see a few thumbs up of when you've got to this point. Thanks. And Sarah, if we can, want to do some polls with everyone in a minute or two. It's telling me that Slido is not ready yet. Please wait until the meeting host starts Slido. So if that can be sorted, please. You'll need to have SPSS downloaded. That was one of the instructions and prerequisites for attending the course today. If for some reason you were not able to download SPSS, even we supplied a link to a free trial version below. But if you were not able to do it by today, yes, there we go, Hoitzi. The trial version is in the link as well. If you were not able to do it as yet, what you can do is just follow along, because I will be showing you the commands and the output as we go along. So ideally, we want you to follow. The idea is that you'd be about 10 to 20 seconds behind. So I do a series of commands and you follow as you see them on the screen. But if you can't, yeah, there's going to be you can just follow along in the video.
Tabo, I think you need to launch it in Zoom to enable us to do the poll.
Hello, Sarah. Are you okay, Sarah?
I think we need it to be enabled in the Zoom controls to allow us to do the poll.
Go settings. Can you go to more? Just check if you can be able to see the polls. Because you've got co-host, right? You can be able to create polls.
Hey everyone, I'm hoping you managed to download the dataset and you managed to double click and open it, and SPSS should open up. Can I have some thumbs up from you if you managed to get to that point, please? Okay, I'm seeing some thumbs up, but not enough yet. Right, so I'm seeing, yeah, still setting up.
Ronald, do you want to try the Slido again in the meantime?
It still says the same thing. Wait until the meeting host starts Slido. So I have some polls prepared. It's just not allowing me to display them in this meeting, which is host permission access. But there's a backup plan if not, Sarah.
Okay.
Can I have those questionnaires? Then I will load them from my end, Tabo.
It's okay, Tabo. I won't be able to send that to you now. Yeah. Right, so I'm going to give it till 10 past and then we will move on. And if you're struggling, you can just find some time in between to open SPSS and open the data set. And as soon as you do that, please just indicate with a thumbs up.
Pavel, can you access it through the app setting as the host?
Yes, I'm going there.
Okay. You'll see it's an add-on or an add-in that you can search for.
Okay, everyone, in the interest of time, I'm going to just to allow us to get to know you a bit better. We have a few questions that we'd like to ask you. So the first is, if you can tell us about, if you can please tell us, what's the strangest thing you did while attending a meeting online? So it should open up a little QR code for you to have a look at. If you can please scan that QR code, and then you can tell us, you'll be able to vote then. What's the strangest thing you did while attending a meeting or training online? This is just a little icebreaker. Was it wore pajamas, ate a meal, cooked your lunch or dinner, brushed your teeth, watched Netflix, and any other thing but your lips are sealed? And any other thing but your lips are. If you can please scan the QR code, and then you should be able to vote and tell us. Okay, great. I'm seeing some responses coming in. That's good. So there's 102 of you online. So if we can get all those responses coming in really quickly, that would be great. Perfect, nice. Okay, it looks like the strangest thing is that everybody's eating a meal, eating something while they're watching their training online. Okay, the responses are growing. It's still eating a meal. Alrighty, I'm going to stop this one. And if you can, the next question we want to ask you is a little bit more serious. So it's, have you used quantitative data before? Have you analyzed quantitative data before? This will help me to see how I should pitch the lesson. Is it no, but that's why I'm here? Or is it yes, I've done basic analyses? Yes, intermediate level or higher. And that will help us decide how fast we go, the pace that we go at, and also maybe what sections to go really in depth into. Let me know if this poll isn't working on your side. I don't quite see the chat, but is everything working fine or not, Gracie or Sarah?
They're struggling a bit with the poll, but I copied the link. They're saying that the votes are closed. But on my side it was not. But please try okay. They're still having issues. Please try the link if you're having issues. Oh, okay. Oh yeah, it says voting closed, Ronald. Yeah, no one can actually vote. I just tried it again right now. It says
Okay,
the
sorry about that.
voting
Try now.
poll is closed.
It should work
perfect.
now. Yeah.
Oh, okay, it's working now. Okay, thanks.
Sorry about that, everyone.
Sorry, Renelle. I see, yeah, we still have more than what? It's only 40% of the participants who've actually tried the poll. So, yeah, we need more responses.
Yes, exactly. Please, everyone, just get into the QR code and let us know if you've analyzed quantitative data before. No or basic analyses or intermediate level or higher. So far, I'm hoping you can see this, but about half of those of you have answered so far. And of those, 46% saying, no, you've not before. And the rest is either basic analyses. We've got about just over a third saying basic analyses. And we've got about 1 in 5 people saying intermediate level or higher, which is really good. If we can rack those responses up to at least 60 people or participants providing an answer. everyone, I'm going to move on to the next question. So yeah, we've got about 40% saying yes, basic analyses. The next question I want to ask you is, have you used SPSS before? Just let me know if you're able to vote on this one. No, not at all. Yes, a little. Or yes, many times. Okay, thanks. This is helpful. So it looks like so far the majority have not used SPSS at all, and about half have not done any quantitative analysis before. All right. As for the 11% who have used SPSS many times, I really hope you will be patient with us today, because as we said in the lesson plan, this is a very introductory level session, and we're going to be covering mostly descriptive stats. So it's mostly about getting familiar with the SPSS interface, opening some data, having a look at what it's contained, and then progressing onto some basic statistical tests. But let's hope this still will be very relevant for you. It will also help to seal in some concepts that you might not be aware of, even though you're using them in your analyses. Okay, so I'm going to stop this poll and go on to some slides that I'd like to present just as an introduction. Again, please actually make sure that you have the data set downloaded, that you double click on the data set, and that it's open in front of you right now. Again, I'm not seeing enough thumbs up that you've done that. It might be that you don't have the software, but if it's that you haven't downloaded the data set yet, then please go and do that and indicate with some thumbs up. Is my screen visible? Wait, see.
Yes, it is.
Okay, great. So everyone, yes, as we said, this is a quantitative research module using SPSS specifically. And I'm Renal Supol, moderated by Khoitsi Maseko, who introduced herself earlier. So we've got the welcome and intros out of the way. Now we're going to have a refresher, which some of this you might have covered if you attended the quantitative theory discussion earlier on this morning. Specifically, we're going to look at the types of variables and the types of statistical tests that we're going to cover today and that are relevant to most data. Then we're going to do hopefully an hour at least or more of practical hands-on demonstrations. And included within this will be reflections on AI and data analysis, how you use it and how it can be used. And then we'll have a discussion session at the end in the last 10 minutes, where you will be able to ask me some questions or ask everyone some questions, and this is open for discussion. We might, just before the reflections on AI session, also have an open Q&A session, depending on how we proceed with time. So lesson plan outline is first, as I said, we're going to navigate the SPSS interface. We're going to open the data set, which is called training.sav. We're going to view our data in the two types of viewing that is available in SPSS, recoding variables, then one- and two-way tabulations, basic descriptive statistics like frequencies, means, medians, modes, inferential tests like chi-square and ANOVA, and then we're going to look at some graphs, and then, as I said, the reflection on AI and data analysis. One of the many types of data that we deal with is categorical data, and that can be of many different forms. One of the forms is nominal data, and that is categories in no particular order. So, for example, a question that asks, did you do a certain thing? And the response options in the survey are yes, 1 is yes, 2 is no, 3 is I don't know. That is categorical or nominal data, where each of the categories don't have a particular order. Or it could be what is sex or what is gender. 1 is male, 2 is female. We also have something called binomial data, which you might know as ones and zeros. You have two categories where 1, for example, is male and 0 is female. There can also be ordinal data, where you have finite numbers of values that are ordered in some particular way, but the distance between the categories is unknown or it's unequal. So, for example, what is your highest education status? Either none, primary, secondary, or tertiary. There is an order there, but the exact distance between those is unequal. Or to what extent do you agree or disagree with a particular question? And 1 is strongly disagree, to 5 is agree. We then have numeric data, and that can be of the form of discrete data, which are counts. So anything that can be counted, like the number of people arriving in a venue or the number of goals scored. We also have continuous data, and that is data that's not counted, but it's usually measured. So, for example, distances, height, weight, body mass index. Your body mass index is an indication of how underweight or overweight or overnourished a person is, and age. And often these things are measured where there's decimal points. For example, a person can be 1.85 meters tall. There's usually decimals along the continuum. So we call it continuous data. Then the types of data analysis depend on the type of data or variables that you have. So for categorical data, our descriptive stats that we do are frequencies, so counts. So example, 50 people are male, and the percentages with sometimes confidence intervals. So for example, 20% are female. And then the inference, when we talk about inference, is what is, so I've described the data. Now, what can you tell me about the data that has meaning? That's what we mean by inference or inferential statistics. And so there we usually do some sort of statistical test. So for categorical data or nominal data, we use chi-square tests to look at the association between two variables like gender and maybe smoking. If we want to see if smoking differs between males and females, then we would often do a chi-square test, which tells us if that association exists or not. We can also do more advanced things like logistical, nominal, or ordinal regression, where we put many variables into the model and your outcome is a categorical outcome. There's also continuous data, and the types of analyses that are applicable to this is for the descriptive statistics, we usually summarize means and standard deviations if the data is normally distributed. You might have heard of that term before. And we can also compute things like medians and modes and ranges. We can have a look at outliers, and we can also plot the data to look at what its shape is showing. The inference for continuous data are correlations, t-tests, and linear and other regression going into more advanced analyses. So I want you to now think of what kind of data you work with in your research, whether it's your PhD, master's project, or the data that you work with every day in the particular project that you're working with. What types of variables do you have? Is your main outcome a categorical or a nominal, or is it an ordinal variable? Is it a continuous variable like maybe income or scores on a test? And then what other types of variables do you have? And what are you trying to get your data to say? Also, what type of study design do you have? Is it everybody measured at one single time point, or is it people who were then followed up over time? Or is it people that you interviewed and you went and tracked their behavior backwards in time? Or did you have an experiment that you designed and you're testing it on two groups of people and you're following those over time? Also, within that study design, what data types are you measuring? What are your dependent and independent variables? A dependent variable is your main outcome, the main thing that you're looking at, and you want to look at all the things that it's associated with. Which statistical tests will best help you answer your research question? And hopefully that's where we can come in and help today. So I'm going to pause there, and we're going to now go into the live demo of the SPSS. So I'm really hoping that you can see what I see. Not seeing enough thumbs up to tell me that you are at this point. But in the interest of time, it's 2:30 now. We've got till 4 o'clock. So I'm going to continue with the demonstration. I hope that maybe you can actually resize this window so that you have it on the right-hand side, and then you have your actual version of SPSS on the left so that you can follow side by side as I go. All right, so we've got the dataset open, and this is a dataset that contains 9 variables, and it contains 1,000 records. So that means 1,000 people were questioned or measured, and at one single point in time. This is cross-sectional. And this is the data that they gave us. So we've got gender, and you can see a series of 1s and 2s here. But I don't know what those 1s and 2s mean yet. So we'll get to that now. And then we've got age, different ages in years. We've got their height in meters, their weight in kgs. This variable here is called FEV1. It stands for forced expiratory volume. And what that means is basically they ask the participant to blow into like a breathalyzer. And then they got a measure of how strong their lungs are. So it's your lung capacity, basically. And that was then this FEV1 PC was converted into a percentage. We've also got smokers having values of 1, 2, and 3. We've got wheeze, which would be whether the person wheezes or not, but that's just 2s and 1s now. We'll get to what the 1s and the 2s mean. And we've got BMI, which is your body mass index. It's a function of your height and weight. People with a BMI over 25 are generally considered overweight, and those with a BMI under 18 are generally considered undernourished or underweight. So if we have a look at which are categorical variables now, what would you say? Feel free to pop stuff in the chat, although I'm not sure if I can see them all. There. So we have gender, which would usually be male, female, sometimes another category or other categories. And that would be categorical or nominal, as it's called in SPSS. We've got smoker, which has just got 3 categories. So categorical or nominal, as you can see, it's showing there. And wheeze is got 1s and 2s, it's nominal. So what I want you to do now is scroll to the bottom of your data set. You can see we have 1,000 different records. Scroll back up. I want you to go to the variable view. Okay. If you see in the variable view, you've got your different 9 variables, and now you can see the different properties of those variables. So we can see here that gender is a nominal variable. If we click on this thing here that says values, we can see that 1 actually means male and 2 actually means female. But it's not displaying that, right? So let's go back into the data view. And let us go to view at the top here. So 3rd from the left, view, and then click on this tick box that says value labels. Once we do that, we can see that this 1 value here actually means male, that this 2 value here actually means female. And now SPSS is telling us what the 1s and 2s actually mean. It's not doing it for smoker and wheeze because they actually don't have their labels assigned to them, their value labels. So let's go and assign them now. So in variable view, I want you to go to smoker. And then we're going to open the value labels for smoker. And then we're going to click on the plus. And I'm going to tell you that the 1 is for never. So 1 is never. 2 is an X, it's an ex-smoker. And 3 is a current smoker. So we've got 1 never, 2 ex-smoker, and 3 current smoker. If you can enter those in and then press OK. And while we're at it, we're going to do that for Wheeze as well. So for Wheeze, we're going to go to the plus sign here. And we're going to enter 1 is yes, the person wheezes. And 2, the person does not wheeze. Right, wheeze is to struggle with breathing. Not sure why I didn't do that. Let's do that again. So 1 is yes. 1 is yes. And 2 is no. Right, to check that, you can click on that and it shows what the value label is. And while we're here, let's just tell SPSS what FEV1 means. Actually means towards respiratory volume, which remember is how strong your lungs are. And BMI, that we know it, is body mass index. And so that's actually labeling your variable. Instead of having the variable called something BMI, we're actually giving it a full label. Or we can even put the question that was asked for a particular thing here so that it's easier to analyze. Let's go back to data view. And then we're going to see now that smoker and we're going to see that smoker and that wheeze now have these values populated in them. All right. Let's now actually go and tabulate some variables and do some proper analysis. So let's go to Analyze. I'm going to go to Analyze. And we're going to go to Descriptive Statistics. So I really hope you're following along and doing this on your side, actually. So Analyze, Descriptive Statistics, and then Frequencies. We want to tabulate, let's tabulate gender. So gender is highlighted and put it in the variable blocks. Let's tabulate smoker. And let's also tabulate height, just for interest. Remember, height is a continuous variable. I just want to show you what it shows. Make sure Display Frequency Tables is clicked. Click OK. So I hope this probably is viewed a little bit smaller on your screen, but SPSS doesn't allow me to make this bigger, unfortunately. So what we can see here is that you've got 1,000 people, as we know, in your sample. 517 of them are male, 483 are female, and the 517 represent 51.7%. So there's 51% of males, 48% females in your sample. Again, any thumbs up if you're on track will help me to know where you are. If there's very few or no thumbs up, I'm going to assume you're just following on the video. All right, so smoker, we have never smokers. We've got of the 1,422 people are never smokers. So that represents 42.2%. We've got 21% being ex-smokers, and we've got just over a third saying that they currently smoke. But if you look here, we've got a 9, and that is just 2 people who said 9. But 9 is not a valid value. So it's actually something that needs to be cleaned up in the data. And so we're going to go and clean that in a bit. And if you tabulate height, you'll see that it's giving you each of the unique height values. But this is not of any use, really. So what we want to do is, remember, height is a continuous variable. So we want to actually summarize the distribution of height. Maybe we want to graph it, which we can do later, or we want to look and summarize its mean and its median, etc. To do that, so let's go and analyze all our continuous variables in this data set. Let's go Analyze, Descriptive Statistics, and instead of frequencies, we're going to go to Descriptives. And here we're going to put in age. Let's do age. Let's do height. Let's do weight. Let's do this lung capacity, FEV1. Let's do the percentage version of it. Okay, so age, height, weight, FEV1, PC. And if you go to the options tab, instead, the standard ones it gives you are the mean, standard deviation, which is usually what you need. But you can also ask for the range, the variance, and you can ask for measures of skewness. You can click OK. And that will give you, you can see that on average, everyone in our sample is aged about 33 years with a standard deviation of 7 on either side. So usually about most of your sample lies between 2 to 3 standard deviations of either side. And the minimum age is 20, the maximum age is 47. Your height, you're on average, we've got a height of 1.7 and an average weight of 72 kgs. So now we had a look at what the data actually is looking like. Let's go and fix the smoker variable. So this is called data management or data cleaning. Sometimes it's called data manipulation, but that's a bit of a strange term sometimes. And we want to go and fix that 9. That 9 is an invalid value. Sometimes in a survey, you have a 9 being like the option, I don't know, I refuse to answer, or not applicable. And usually we want to convert those to a missing response. So to convert that to a missing response, what we're going to do is go to transform. Transform, and here you can actually calculate new variables. Compute variables where you can divide another variable by another or add many variables together to make a scale or whatever you'd like to do. There's many options here which you can explore. The one we're going to look at is recode into same variable. So recode means to change the data some way, but into the same variable and not creating a new variable. The one we wanted to look at was smoker. So smoker, I'm going to put that in. I'm going to select old and new values. I'm going to say the value here that I want to recode is the 9. So the old value is 9. And the new value, I want to make it a missing. So 9 must be missing. Add it. So in SPSS, missing is called system missing, sysmiss. Let's continue. And let's say, okay. And let's go and see what that actually did. So we go to analyze. We go to descriptive stats, frequencies. Let's go in this tabulate smoker to check that it did what we wanted it to. And we can see that, okay, the 9 is actually gone. So now your data, your valid values for smoker are now 998. So it's taken up those 2 values. And now your categories are only never X and current smoker. So I see we're just before quarter 2. I want to code one more variable to show you how you can recode smoker into another variable. And if this time we will see how far we can get. And maybe at 10 to 3, we will just pause for answering questions and a discussion. So say I wanted to, I've got 3 categories of smokers. So you've got those who've never smoked, and those who are currently smoking, and those who've given up, they're ex-smokers. What I want to do is I want to further analyze those who've just ever smoked versus those who've never smoked. How do I then create that variable? So to do that, we recode smoker, where we say the never smokers, they stay as never smokers. And the ex and the current smokers, we put them into one category on their own called ever smoke. Because whether they currently smoke or whether they've smoked before and they don't anymore, they both have ever smoked. So let's go and recode that category. So we're going to go again to transform and recode into different variables. And the variable we want to recode is smoker. So we'll put that into That's our input variable, a smoker, and we want to code it into ev smoker. So I'm recoding smoker into ev smoker. Let's change that. And I'm going to click on old and new values. I'm going to do this really quickly. If you're following, you can. I'm going to say the 1 must still be a 1. And now I'm going to say that the 2 all the way to the 3 must be called a new category called ever smoker. So it should look like this. 1 is a 1, and the 2 in the range through 3 are a 2. And then I'm going to go and continue. I'm going to say, okay. Right. I'm going to show you something. I'm going to go back and do as if I'm doing that all over again, and it will pop this up again. So it has done what I've asked it to do, but I'm going to go and click paste. What this does is paste my analysis into a syntax window. I'm not sure if you're familiar with the term syntax window, but it's going to create a file that's called syntax1. And basically this file has all the commands that you can possibly run in your data set and in your analysis. And say you wanted somebody else to check your work or to check your analysis and look through your thinking. What you then share with them is you could share your output, but you could also just share this whole syntax window so they can actually follow your logic. So let's put that on the side there for a little bit, and let's go back and see and edit our variable called smoker. So you can see it's put in a value called smoker, ever smoker, and it's got values of 1 and 2. But we need to tell it what 1 and 2 mean, right? So we have to go back into variable view, we click on the values, and we say, okay, 1 is an ever, oh sorry, 1 was a never smoke. And 2, they ever smoke. Say okay. And so now it's looked at that. Let's go and tabulate, and you don't necessarily have to do this, but let's go and tabulate, see what ever smoker looks like. You can see that those who've never smoked are still the 42.2%, but now those who've ever smoked are 57.6%. They include this ex-smoker and current smoker. If you add these two up, they will add up to 57.6%, which is what this is doing. All right, so that brings us to the end of recoding variables. And I want to now do a two-way tabulation for you to show you what two categorical variables look like. So say I wanted to look at ever smoker and gender. So have males smoke more than females ever in their lives, or have females smoke more than males ever in their lives? Which one is it? Say I wanted to do that. So you're looking at the association between two categorical variables. Can your data say something important about them? Is there a significant association between gender and whether you've ever smoked? How would I actually answer that question? And in order to do that, what we do is a cross tabulation. So cross tabulation is when you're looking at two categorical variables. One is in a row and one's in a column, and you look at what they look like. So let's do that quickly. We're going to go to Analyze. And we're going to go to Descriptive Statistics. And then to Cross Tabs. And to do that, we're going to, usually you want your outcome in the column and then you ask for row percentage. That will make sense in a bit. So let's put our gender in the row. And let's put ever smoker in the column. I'm going to click on the statistics. I'm going to ask for a chi-square test. Remember, we spoke about that in the slides. And I'm going to ignore all of these others, but you can browse them. They might seem familiar from any stats courses you've done, and then continue. And then click OK. Now, I'm going to see if we can make this bigger. Or perhaps you can make it bigger on your side if you just zoom the window. But what we can see here is, all right, let's go back and do that. I actually forgot to do something. So descriptive stats, crosstabs. Let's go back here in statistics. Also cells. We go to cells. I'm going to ask for the percentages, not just the counts. What it gave me before was just the numbers, but numbers are not really important. What we're interested in is percentages because those are more relative. So continue. Okay. And now we're looking at this cross-tabulation of gender and ever smoker, and what we can see here is that among the 515 males in our sample, 60.4% of them have ever smoked. Among the 483 females in our sample, 54.9% have ever smoked. So what are we seeing there? Looks like we're seeing ever smoking is higher amongst males than females. 60% versus 54%. Okay, that's something. But is that worth talking about? Is it worth mentioning? Is it statistically significant? If something's statistically significant, it's kind of worth talking about. So how do we test whether it's worth talking about? And to do that, we look at the Pearson chi-square. So at the bottom where it says chi-square tests, we've got Pearson chi-square. And we look at this asymptotic significance two-sided. That means basically it's a two-sided test, and that's your p-value. So a p-value that is less than 0.05 is significant. Any value less than 0.05 in p-value is significant, it's important, it's like, yay, I got a good finding. In this case, 0.078 is not less than 0.05. So what we conclude is that smoking status doesn't differ significantly between males and females. Even though it's higher in what we can see, it might just be due to chance in the sample. The data are far too spread out for it to be due to having any meaning. It might just be due to chance. So we can be 95% sure that there is no significant association between gender and smoking, or no significant bivariate relationship, at least. And I'm going to pause it at that. And Khotsi, I'm going to hand over to you to facilitate any Q&A. So any questions that we may have for the next 5 minutes? Thank you very much. Any questions we may have for the next 5 minutes? And after that, discussion of what AI is. And let's hope these polls get time. Thanks.
Thank you, Ronelle. That was very, yeah. For most of the participants here who had no idea on what SPSS was and how to use it, you've really helped us a lot in understanding. And I see a lot of the participants were not able to get SPSS yet, but yeah, they were able to follow. Okay, so from the chat, we only had one question. So this was when you were explaining to us the data types as far as the variables were concerned. Lesetja Manguru wanted to ask or wanted to know, where would we put performance measurements? Yeah, that was the one question we had for now.
Okay, thanks, Lesetja. We thought that we would make this a little bit open so IT, if we can, unmute participants' microphones. And then maybe, Lesetja, you can tell me what you meant by that question, because I'm not sure what you exactly meant. So it'll help me to answer it. Yeah, performance data can be measured in a variety of different ways. So you can have a binomial value saying, yes, the person performed, they achieved their performance score. I don't know, what's the pass rate? Anything above 50 out of 100. So yes, they achieved performance. Anything below 50 was no, they didn't achieve any performance. So that could be a yes or a no, performance or not. Or you could have performance as a scale from 0 to 100. You can lie anywhere on that scale. Sometimes there's scales, and when I say scale, I mean like you can have 10 different questions assessing performance, and you can have different answers for each of those questions, and you use all those 10 variables to come up with a composite indicator of your performance. So I'm not sure exactly what you meant there, but that's just to give you some insight into many different ways that you can measure performance data. Depends what you have in mind. Okay, I see. Understood. Thanks. Any other burning questions? And you can raise your hand, and then we can unmute you, and you can go ahead and let us know.
Yes, I have a question here. Yeah.
Hi, Clement.
Yes.
Please go
Where
ahead.
you have to design the variable in the variable view, where you want to design the row, what you are measuring. Sometimes it seems to me it doesn't matter if you put it on that scale or not, the calculation still works fine. Does it matter that you have to put it on scale, or you put it in a certain category of the variable before the calculation can work perfectly? Or it really doesn't matter because it sometimes works, but is it risky? Is it a risk, or is it a problem that that scale has to be well defined at all times in the variable view? Thank you.
Thanks, Clement. That's actually a very good question. So it depends on what you want to do with the data. Sometimes you might not have to define that this is an ordinal variable or a nominal or a scale or what have you, depending on what you want to do with it. But I think that SPSS, if you specified that something is a nominal variable, it'll start treating it as that. So say you want to go and do further things beside a cross tabulation. You remember when we had that height variable and we tabulated it, and it gave us all the different unique height values. It was treating it as a continuous variable. I think that if we made it a nominal variable, it actually wouldn't even allow it, or it would give us some error terms when we had to do further analysis. So I would say that as a guideline, just inspect your data, know how it's collected, and be specific. Almost all stats programs want you to say that this variable is a nominal variable, this one is a continuous variable, and be able to recognize them. So as a guideline, yes, do it as far as possible. But if you're not sure, then you can just, if something's, maybe account data and you want to call it continuous, I think it would be fine, but you'd only actually find out once you get to further analyses how that's getting treated. And when, in the case of you being unsure, it's always helpful to consult, if you can, a statistician or someone who knows quite advanced analysis in your university or in your department. I hope that clarifies it a bit. Okay, perfect.
Hi, Ronel.
Thanks. Hi, Huizi.
Hi, we have two more questions from the chat. Okay, so the first question is from Oluwadamamilo from Lasabi. And the question is, for the BMI variable, how can I put it into categories and graphs?
Thank you so
Yeah.
much for the question. Would you like to unmute Are you talking about the BMI, your own BMI dataset, or the BMI variable that we have in this dataset?
The one in the data set.
The one in the dataset. Okay. So the one in the dataset, let me share screen quickly to answer that. All right, so the one in the dataset, as you can see, how do I get rid of this? All right, the one in the dataset, as you can see, it's a continuous variable, a scale variable. If we had to tabulate this variable, it would have lots of little different categories. If you wanted to make this into categories to see who's overweight, who's normal weight, who's underweight, what you go and do is recode. Remember how we recoded 3-category smoker into just 2 categories for ever smoker? So we go and do the same thing for BMI. We'd go and transform it, and then we'd go on to recode into different variables, and then we'd go recode BMI here. And we go and code that into BMI, let's call it. And then where it says old and new values, here I'm just going to show you an example. Like say this one, your minimum value, whatever your value is, the lowest BMI, all the way to 18.49999. That will be called underweight. Oh, where did that go? So for example, 18.499 will be called 1. And then that will be your underweight category. So you'll go and code that, and you'll code all your different ranges so that you include the full range of data so that you'd get an underweight category, a normal weight category, an overweight and obese category. And that's how you code BMI into categories. And then you go and tabulate that variable and see what that looks like. Does that answer your question? Would you like me to actually do it and show you?
Please, if you can. If you can, I will appreciate that.
Okay, sure. Let's do this. Right, so 18 comma. Right, then the next one is so 18.5 to 24 point will be called 2. So 18.5 to 24.9 is normal weight. Then 25 to get 29.999 will be called our third category, and that's overweight. And the largest category is obese, and that is 25 through to, no, sorry, that's 30. 30 through to 30 through to the maximum, actually. Let's do it there. 30 through maximum. Cool. Let me just check that. So yeah, looks right. Continue, and then I'm gonna paste that into my syntax window. Where is that? Okay, so you can see this is actually the syntax for coding it. I'm going to put that into the chat just in case you need it. And if I highlight this, so I could run it through my window there, or I could just highlight this, and I could press this green button which says run selection. If I run the selection, it should have created that variable for me. Hoping it did. There we go. So we've got BMI category, it's got various variables, values of 1, 2, 3, 4. I go to BMI category here, And
Sorry, Ronel.
let's see. Yes, Swati.
We lost your screen. We can't see your SPSS anymore. Yeah, just now when you were doing the BMI, just this time. Yeah.
Is it showing now?
Yes, yes. Thank you.
Perfect. Not sure what happened there. Wait. Okay. Overlay. It's obese. Okay, so let's go tabulate that variable and let's see who is in what category. So descriptives, frequencies, let's go see BMI category. And let's go see, okay. So here we go. This is, I hope this is visible. Right, so we can see the BMI categories. We've got 1.8% who are underweight. That means their BMI is below 18.5. The most are normal weight, 63.8%. 26.5 are overweight, and we've got about 8% who are obese in this particular sample. So that's how we classify a continuous variable into a categorical variable. But thank you for asking that question, because that was actually one of the things that we were going to do next. We were going to recode age into age categories, and we were actually going to use an AI prompt to do that. But I will show you how that's done just now. Yeah. How do you decide? Perfect, thanks. How do you decide on which variable do you put in the row or column when doing a crosstab? And let's share this again. I think that might be the last question that we take, just in the interest of time. So let's go and look at the gender and ever smoker, if we remember. So yeah, do I put gender in the row or do I put gender in the column? I'm going to say this and maybe you can write it down just so you remember it. Generally, what I like to do is whatever your outcome that you're interested in, if it's smoking, if it's BMI category, if it's income category, whatever category is your outcome of interest, you put in the column. And whatever we call it, your independent variable or your explanatory variable, in this case it's gender, you put in the row. And then you must ask for a row statistic. I'll show you what that is. Analyze descriptive statistics, crosstab. So you remember we had gender in the smoker. When you go to cells, this is really important. When you go to cells, you must ask for row percentage, because row percentage will tell you among the people in your row, so among the males or among the females, this is the percentage that smoke. So among the explanatory variable categories, this is your outcome. And then you'd go continue. All right, so I'll just paste that in as well. And you can see that's also pasted in. So here's the syntax for doing a cross tabulation. If you had to run that, it would give you the same cross tabulation. And then you can share it with somebody else and they can replicate your work. So here, tables gender by Everspoker. And you're looking for a row percent. Right, so that is, hope that answered the question, Milo. And yeah, Quincy, are we okay for time? I think now we're going to go into just having a discussion on AI.
Yes, yeah, we're okay on time, Ronel. You can go ahead.
Perfect. So I want to check, are you able to, Quincy, are you able to do that poll on your side? Otherwise, I think mine should work.
No, I can't do it on my side.
Okay, cool. Let me see. Let's go to this one. All right. Share again. All right, I'm going to ask you firstly, how do you use or have you used AI in data analysis? And then I'm going to ask you about how you feel about the pace we're moving at. So first question, starting, I hope it's visible. Let's see. If not, okay, perfect. Yes. All right. So is this visible? How do you use or how have you used AI in data analysis? And please limit your response to up to 4 words. And if you've never done it, then you can even just say never. I'm not sure if it's going to ask you to scan the QR code again to vote, or if it should allow you to just vote again. I'm not sure how it's going to work. Okay, yeah, right. Great. I see participants typing. All right, I'm going to give you a minute to reflect on that and just give me your responses. Let's see what people are saying. Okay, yes for the systems, never. What else is coming up? Never. Yeah, lots of nevers. Well, I suppose it is a strange question to ask because in the beginning we did ask you if you view how familiar you are with data analysis, and about half said that you're not familiar with quantitative data analysis at all. So I guess you obviously wouldn't have used AI in quantitative data analysis. Okay, improving flow, NSV, yeah, maybe that's never, and maybe that's something else. Yes, for the systems, generating visualizations, that's really good. That's very good. And some never. So maybe those who said that they're intermediate level analyses, they do intermediate level analyses, we'd like to hear about how you use AI or how you have used AI in data analysis. Summarizing, right? Never. Summarizing where necessary. Unsure. Unsure is good. Okay, it's guided me a lot. I like that one. Generating syntax. Yes, we're going to be doing that now. Cleaning data. Yeah. It would be, this is an interesting crosstab. It'd be nice to know of the people, of the participants that have used or do use data analysis, they do data analysis, what percentage of them have actually used AI for it? But I'm not able to see that in this. Okay, identified gaps and clean data. Yeah, visualizations guided me. Perfect. Okay, we've got about 32 participants interacting here. All right, so I'm going to stop this poll. And that is that. And before I actually go and present something on this discussion, I just want to ask you so that we know how to, we've got a little bit of time till 4 o'clock. So should I move slower? Should I move faster? Or is the pace just right for you to follow? And yes, I do understand that some of you don't have SPSS or don't have the data set. Well, I'm glad nobody's saying we can move faster. I'm quite relieved about that. Okay. So from what I'm seeing, 60% are saying just right for me to follow, and 40% are we can move slower. So being the quantitative analyst that you are now, I will have to go with the majority, which is to keep at the pace, also to ensure that we cover the content. And if you're wanting to move slow, remember there is also the recording. You can always go back to the recording and follow along step by step on your SPSS when you have the time to. So let's stop this poll now. Let's go back into the slide that we had. All right, I'm hoping this is visible, the reflection slide in PowerPoint.
Yes, it is.
Okay, thanks. Let's see. All right, so this is where we left off, and now we're going to talk about reflections on AI and data analysis. So I've already asked you how you used AI in quantitative data analyses, and you've given me all sorts of answers, including data visualization, summarizing your data, helping you guide or understand your analyses better. And the bulk of you were saying never used it for analyses before, but maybe you use ChatGPT in your everyday life, or maybe you don't. We don't know. But what I want to then talk about next is issues of confidentiality. So AI is creeping into your lives, and for some, like I said, you might be using it for various things every day. In research, in fact, they use it to complement and to speed up our work. But I'd like to talk about the responsible use of AI and how that's used confidentially. So most importantly, when you have a data set, do not paste it. Do not paste raw data into AI systems unless you have explicit approval from your organization or whoever is the owner of the data, and you must comply with the applicable data protection or data sharing requirements in your organization or whoever is the holder of that data, whoever that belongs to. Datasets can have sensitive information, like they can have IDs or even geotags, especially on data that's that's collected remotely. Even other sensitive info that can allow a participant to be identified, or it can allow the system to generate inference or to make summarizations about an area or location or a group of people, and that is risky. Because once you've put that data into an AI system, there are risks involved, and it's important to know that it can be dangerous and there are risks involved. And so, yeah, you have to just respect the data protection, the ethics, the data sharing or donor rules, and your organization's policy. So rather than get AI to analyze your data, it's important that you actually understand your data. You can rather use effective prompts in AI to get the correct information about how to understand your data, how to plan your analyses, maybe even what test to do or what analysis to do, and then how to interpret your output. If you've been attending these sessions, as you know, AI is at the center of a lot of this week's training, and a lot of the times they would talk about the responsible use of AI or keeping a human-centered AI or like keeping the human in the loop. What does that actually mean? It means that you are the scientist, you know your study, you know your data well, you are the expert in it, and you need to have control over that. You need to be the one that understands your analysis well, so that if you have to present this in a wider audience somewhere at a conference or whatever, you would know the intricacies of your data and not have to say that, oh, well, AI did this and this and this for me, and I actually am not too familiar with certain things. So AI should just be used to complement and enable your work, and you should still be the human or the scientist that's in the loop and is in control of it. So that's just a word on confidentiality. But like I was saying, you can use AI systems to help you understand your data. And one very important use of it is to generate codes or syntax. And also you can put in output, or you can describe the output to the system, and it can help you understand. So for example, what I was showing you now about how to code the BMI category, you could actually ask it that, and it would help you to understand how to code that variable. It can even give you step-by-step instructions. Click here, then click here, then click here in SPSS. So let's do an example now. I am going to, like we did for BMI, we coded it into categories. So coded a continuous variable into categories. We are now going to code my screen's still, okay. My screen's still visible. We're now going to code an age variable into categories. So this is ChatGPT. Some of you may use it, some not, and some AI bot, but you might have various others that you use. Some use like Microsoft Pilot or whatever it may be. I hope you can hear me. Saying my internet connection is unstable.
Yeah, we can hear you
right
now.
Okay, perfect. So I'm going to ask it this particular thing. I'm going to just copy this in. I'm going to ask ChatGPT, and I want my prompt, this thing is called a prompt, whatever you ask it, to be as specific as possible. If it's not as specific as possible, then it can make mistakes for you. So I wanted to write SPSS 31, is my version of SPSS, write SPSS syntax to recode a numeric or a scale variable that's named age into another variable called age group that has categories. So it's a categorical variable I want, and I want these categories. Less than 25, 25 to 34, 35 to 44, and 45 and older. And I'm going to ask it that. Send a prompt. And there we have it. So it's given me some syntax to recode age into a new categorical variable called age group. And this will create the following categories that I asked for. It's got some other notes about even going on to missing values, which we don't have a problem here, but it's thought of everything. So I'm going to copy this code, copy, and I'm going to go into SPSS. Let me know if it's not visible, and I'm going to paste that in. Yes, Marcel, you can go ahead.
Yes, thank you, Dr. Tekri. I just wanted to know, because I use SPSS, and I use actually AI to have, and AI generate a syntax to get to transform the variable the way I want it. But the problem is the variable was, because SPSS is giving the variable in alphabetic order. So, but actually I wanted the opposite. So I didn't know myself how to, I don't know if there is a way to understand the syntax and to transform it so that we can get it straight from SPSS the way we want. For example, if, as I said, the result that I got was in alphabetic order, rather to be in the way I really wanted on. So I don't know if you can help on that side.
Okay, thanks, Marcel. It sounds like a very specific question. So if you'd like, you can pop me an email and I can help you to recode that variable in the way that you want. If AI is not helping you, maybe it is down to the prompt. Like I was saying, be as specific as possible. So maybe say, you are giving me these alphabet categories, but what I specifically want is this and this and this, and it could help you. But yeah, feel free to pop me an email and maybe I can help you on that unique question. Thanks. Okay, so we've popped whatever that syntax that it was. So usually, if you know SPSS syntax, and I do, although I have to admit I'm a little rusty because I use some other software these days, but if you know SPSS syntax, you'll know that this is the correct way to recode that age variable. And what's cool is that it's also, instead of manually assigning those variable labels like we did with the BMI, it's given you the syntax to assign those value labels of less than 25, 25 to 34, etc. Automatically. So I'm going to highlight all of this to recode my age variable. And I'm going to click the green button that says run selection or execute. It's going to run it. And so you'll see it's run it, or it's not showing here, but you can see in the data that it's created this variable here called age group, and it's given me all my categories. Let me go and now see what age group looks like. So analyze, descriptive stats, frequencies, and age group. Let us tabulate that, and there we have it. So on your own, this might have taken you, a lot if you were not familiar with the syntax, but with the chatbot, it obviously has lessened our time to recall this variable if you can't. And sometimes you might have a spelling mistake, somewhere in your code, and this is where it can help you to debug that. But also a word of warning, make sure your prompt is specific. Go and validate that this is actually what you wanted to do, because AI can make mistakes, and it does regularly make mistakes. I know that, and I can tell you that from lots of things that I've asked it. So here we can see our different age categories and the percentage that belong in each age category. Going back to the chatbot now, I hope it is visible. So I'm also going to ask it, instead of code, I can also ask it to guide me. Someone said guide me, to help me understand what analysis I should do. So let me ask it this prompt here, which is actually what we're going to do in this next session up until 4 o'clock. If I have a 2-category variable of smoking status, and I want to check if lung capacity, which is a continuous variable, remember it was that FEV1 PC, if this lung capacity varies significantly between the ever smokers and the never smokers, then what analysis would I conduct? And I know the answer, but sometimes we might not know the answer, and we just need to check, and we're not sure, or we need some options of available possibilities that we can do. And this is a reliable, this is a resource to tell us. And you can see it's telling you, it's breaking down what your independent variable is, which is smoking status, what your dependent variable is, which is lung capacity. It's telling you the types of variables that each is, and it would tell you the statistics test you need to do, which is a 2-sample or independent sample t-test. It's telling you all the assumptions you need to make before you can go through with that t-test, which we'll also get to in this next session. And then it's even telling you what you would click on where in order to do that. All right, so it's helping you to understand, oh, I think maybe I should do this t-test, but is that the right thing to do? Let me see what my options are. Or you could say, what are the other options that I have? And it will tell you. Right, so going back very quickly now, I want to, so we've discussed the confidentiality, we've discussed how to plan our analyses informed by good prompts. And then now, what is machine learning, which is the last thing I talk about. I wanted to talk about this because AI is often a very foreign term. We're like, oh, artificial intelligence, what is that? It speaks to me and it tells me a whole lot of stuff, and it's like a human. But one of the precursors and one of the things that is contained within AI is machine learning. And machine learning is actually one of the foundations. It was informed by traditional statistical methods, and then how to build these machine learning algorithms. So it is a subset of AI. What it does, it's the flexible algorithm. You've heard of an algorithm, which is like a open-ended program, and it feeds large amounts of data into this algorithm, and then it allows the machine to learn from the data to either find patterns in the data or to make predictions about a particular outcome. So you train the model using some training data, and then you test it to see how accurate it actually is. So this is like a flexible algorithm instead of like a specific statistical model that is programmed into a computer, and it says if you have this, then you do that. If you have this, then you do another thing. And it's very solid and restrictive logic, whereas the machine learning is a little bit more flexible. So in our example that we've been looking at, one way that you could use machine learning is, we've got smoker, we've got BMI, we've got all these values. Say my outcome was lung capacity, FEV1. And say I wanted to predict lung capacity. But instead of just my 9 variables, I had data from like 100,000 people from a biobank, and I had data that included their BMI, their lab tests, a whole lot of blood sample information, maybe even genetic or epigenetic data collected on them, maybe even, a whole lot of behaviors, not just whether they smoke, maybe their physical activity levels, how often they exercise, what type of exercise they did, etc. All of that you could put into a machine learning algorithm, and you could ask it to predict the person's lung capacity. And then we could test how good it was using the lung capacities that we have measured. And then that could be used further as a model for predicting lung capacity in people in other populations. So that's just one example of a real far extension of the data that we're using, and how can it be expanded and used in machine learning, which is a subset of AI. So I think that is enough of an AI overload. And Hwetsi, if I have your permission, we can go back into the training, or is there any other burning questions before we go into the session 2, which should take us to 4 o'clock?
We actually have three questions that I think maybe you can just quickly assist with. Okay, so the first question that we missed, it was from Regina. So Regina was saying that you were moving too fast, but when recoding into same variable. So this is when you were recoding into the same variable from 9 to missing. How do I do that, since missing is not a number? So that's one question. They just want to see how did you make the 9 the missing? They missed that part. And then the next question, okay, you've already responded to this one. It was from FRD Bierkes. They were asking whether there would be a similar mechanism for qualitative survey. So I suppose what they're asking, if there's a similar training for qualitative survey. And then the last question from Munkhogi is saying, if I'm using a secondary data set, such as extracts from student grading system, is it still considered quantitative data? And do I have to run tests such as the Cronbach's alpha and normality tests? Thanks, Ronald.
Okay, thank you, Hwetsi. Thanks everyone for your questions. So yes, so qualitative data is usually you're asking, how did you do this thing? What did you go about? And people can respond to you in sentences and paragraphs, and that's qualitative data, where you're not just dealing with a single number representing a value, or a value representing an income or a student grading. You're dealing with a whole long paragraphs of data. So there is a separate training within this academy. I'm not sure which day it is, that deals with qualitative data. Mine is particularly quantitative data, which is all your numbers and stats. And yes, if you're using a secondary data set with student grading, if that data, I would assume that data is quantitative data. If you've got numbers and values representing student grading instead of paragraphs and words, then you can use quantitative data analysis. And yes, you would have to run tests such as Cronbach's alpha and check for normality. Yes. All right, I think that answers it. And then for the one about the recoding into the same variable, let me just go over that quickly, and then we'll go into a t-test. All right, so we've got, looks like you understood how to recode into different variables, because we recoded BMI, we recoded smoker, we recoded age into different variables. So to recode into same variable, remember we had smoker and it had never, X, current, and then it also had a 9 category. So when I go on old and new values, the code to use is 9 to sysmiss. So in Stata, in some programs, a missing is like a dot, or a missing is a space, or missing is actually some coded variable called miss. In SPSS specifically, sysmiss, SYSMIS, is the code for a missing value. So you code 9, the value that you're transforming is 9, and you don't put it as a value here, you put it as system missing. And then that's what you would execute. So I hope that it's telling me that because I've done it already. So I hope that that clarifies it. And when we tabulate that smoker, it will get rid of that 9 and it will convert that 9 as if it's a missing response. So instead of 1,000 variables, you'll have 998 because those other 2 have been considered missing. And then you'll just have the 3 categories left. Okay, I hope that answered the question. The next thing we're going to be doing is looking at some graphs. And I'm going to speed through these because, again, like we said, time is not on our side. So I'm going to just to show you, because these are all the possible graphs that you can look at. If we go to 1, 2, 3, 4, 5, 6, 7 from the right, we have graphs, and we can have all these different types of graphs, which you're probably familiar with: bar graphs, line graphs, histogram. But I'm going to go to a histogram, and that shows the spread of the data. You can, you can have fun exploring all these different types of visualizations in SPSS. And what I'm going to plot is this lung capacity, the percentage version of it, FEV1 PC percentage. I'm going to look at just that on its own. Okay, and this is what it looks like. So you can see it kind of has like a bell, we call it a bell shape. And that bell shape is kind of indicative of suggesting that it might somehow have a normal distribution. And normal distribution means that it's got this bell shape. So most of the data is centered in the side, and you have about an equal spacing of the data on the left and the right of your most common observations. So we can see the mean is 106, standard deviation is about 13 on either side. And yeah, normality, having this as normally distributed, is actually one of the assumptions that we're going to need going forward. You can do a formal test for normality, but I'm not going to get into that now. Let's also look at a histogram, again, of the same FEV1 PC, but I want to look at the lung capacity for smokers, ever smokers, and never smokers. So let's go to ever smoker and put that in my row, right? So your outcome by your row. Let's see what that does. So here you can see for the never smokers, this is my distribution of lung capacity. And for my ever smokers, this is my distribution of lung capacity. They're not put side by side, but you can see both of them roughly have most of the data concentrated in the center, and they have sort of that what we call bell shape, which is also suggesting that they might be normally distributed within each category. But again, I would need to check for that properly. One of the other options that you can do, and which I'm not going to do, is graphs and a scatter plot. You can see a scatter plot allows you to look at a whole lot of variables along each other. And you can, you can look at the scatter plot of maybe BMI and age. Does BMI increase with age? And you can see a rough pattern in the data. You can also look at bar graphs, and as I said, quite a few different graph options there, which I'm not going to get into right now. What I am going to show you is our next test, which is whether a continuous variable like our lung capacity is significantly different between two groups. So my research question that I actually want to understand is, do ever smokers and never smokers have different lung capacity? And I might have a hypothesis about that. I mean, what we know about smoking is like, okay, well, maybe the ever smokers have a lower lung capacity. That's what I hypothesize. But does my data actually suggest that? And whatever it's suggesting, is it meaningful? Is it statistically significant? So to investigate that, what I do is I go analyze, and I'm going to go to, instead of descriptive stats, I'm going to go compare means and proportions. And I'm comparing means because we're dealing with a continuous variable, means. So I'm going to look at FEV1 as my dependent. Remember, my outcome variable is my dependent variable. And my categorical variable is ever smoker. It's my independent variable. And yep, let's do that. Okay, so it says shifted right to the bottom. Oh, there we go. So what you can see here, you can ignore all that on the right. But among the never smokers, their average lung capacity is 107. There's their number of observations, and there's the standard deviation. Among the ever smokers, their lung capacity is lower. It's 105. So, wow, it is actually as we expected. The lung capacity of the ever smokers is lower than the never smokers. So in other words, their lungs are weaker. But is this meaningful? Is this just by chance that we observed it in this data set, the sample, or is it actually statistically significant? Let's test that. So we know what it's looking like descriptively. Now let's do inference. We're going to go to analyze, and we're going to use a t-test. We're going to go compare means and proportions, and then independent sample t-test. Independent means the two independent samples, so the ever smokers and the never smokers, they're independent of each other. Like a person can't be an ever smoker and be a never smoker. They're either one of the other. So they're independent of each other. So there are assumptions that I just want to quickly get into before we do the t-test. And that is that the dependent variable, which is lung capacity, must be continuous for you to do a t-test. We've established it is. The two groups are independent. Yes, you can't be both an ever smoker and a never smoker. They're independent. The lung capacity must be about roughly normally distributed within each group. And yes, according to these bell curves, they roughly have that normal distribution shape, but we didn't fully test that. And then the variances in the smoker, the variances of the lung capacity variable within the ever smoker and the never smoker categories should be approximately equal. So we haven't tested that, but luckily SPSS has a test within the t-test to allow us to do that. So if those four assumptions are met, you can use a t-test. Right, so we're going to go analyze, compare means and proportions, independent samples t-test, and then our outcome test variable is FEV1-PC. Our independent or grouping variable, they call it here, is ever smoker. So grouping variable, and it asks us to define the groups. It only has 1 and 2, so we're going to continue. And then where it says homogeneity of variance test, we want to click that because that's the one assumption we need to test. And I can paste that syntax, which I might just do. Let's see if it pasted it. Yep. And I can go and run it again. Okay. So this is looking like a lot of output, but let's interpret it. So here the first table shows us what we showed before, that the never smokers have a mean of 107, the ever smokers have a mean of 105, and that now we're going to go here. We're going to skip that table and we're going to go onto our assumption table. So if this p-value is less than 0.005, which it is, then it means that equal variances can't be assumed. We reject that hypothesis. So we have unequal variances, which means that in the group of the smokers and in the group of the never smokers, the variance of FEV1-PC is not equal, it's different. So because of that difference, we use this equal variances not assumed test and not the one above. We use the test for equal variances not assumed. This is my t-test results. And we look at the t-value, which you often present in your articles. So this is 2.1. And we look at, most importantly, the two-sided p-value. So it is a p-value of 0.033, and that tells us that there is a statistically significant difference in lung capacity between ever smokers and never smokers. And so therefore we can say, yes, there is a significant association between smoking status and lung capacity. And obviously that's just when we look at those two variables. Sometimes, you have a data set of lots of different things, and the person can say, okay, but maybe your relationship is also affected by the age of the person, or maybe how often they smoked. And that's when you do more advanced analyses. And usually that takes you onto regression models, and you look at after you've adjusted for age and after you've adjusted for how often the person smokes, then do you still see a significant association between smoking and lung capacity? Do you still see that the smokers have weaker lungs than the non-smokers? Do you still see that? Or after you include all those other variables and all those confounding factors, we say, does your association still persist? Is it still meaningful? Is it still worth publishing? And yeah, so that is the t-test. If you would like, you can present the effect size. Often the effect size is this one called Cohen's d, and your estimate is 0.13, which is quite small. That's why you don't have a very small p-value. So it's like there's only a difference of 0.13 between the never smokers and the ever smokers. But it is because of this confidence interval. This confidence interval doesn't contain 0. So it is meaningful. It means that it is this difference between the smokers and non-smokers and their lung capacity is significantly different from 0. So yeah, it's worth talking about. It's not extremely large, but it's worth talking about. We've got 2 minutes, and I'm going to use them to show you what we call ANOVA, analysis of variance. And I'm going to just squiz quickly through that, and then we're going to have an open discussion at the end. So I wanted to look at whether lung capacity was different between a two group variable, never smoking and ever smoking. What if I wanted to look at whether lung capacity was different across a 3 category variable? So if I wanted to know if lung capacity was different between never smokers, ex-smokers, and current smokers, do the 3 of them differ in their lung capacities? And so the rule of thumb is when you want to look at whether a continuous variable differs by a categorical variable, when the categorical variable has 3 or more categories. So ex-smoker, never smoker, current smoker, that's 3 categories or more, then you use what is called an analysis of variance, or ANOVA. So we go to analyze, we go to compare means and proportions, and we go to one-way ANOVA. For that, we look at our outcome, again, is forced expiratory volume, PC, and our categorical variable is smoker. This is the 3 put it here, it's my factor. So this is the 3 category variable. And then I go, okay. What we can see here is, this is showing you a whole lot of stats, but what you really want to know is this F value that you present and the significance level. The significance level, this is really small. It's way smaller than 0.05. So it means that your finding is significant. What is your finding? Your finding is that there is a significant difference in forced expiratory volume or lung capacity between any of the pairs of the three variables. So, for example, it could be that lung capacity differs between ex-smokers and never smokers. It could be that it differs between ex-smokers and current smokers, or it could be that it differs between never smokers and current smokers, between any of those three pairs in your three category variable. If so we've established that there's an association between lung capacity and the type of smoker that you are, whether it's never, ex, or current. But where does that actual difference lie between which possible pairs? Is it between never and ex, current and former, etc.? Which particular pairs differ? And in order to do that, you would go and do a t-test, and you would go and see, okay, I want to do a t-test, and I'm testing my lung capacity, and I want to test it between the ex-smokers and the current smokers, and give me that p-value. And then I go do a separate t-test for each pair of categories within the smoker category, within the smoking categories. And then I'd be able to answer that question. So that we're at 10 to 4. Thank you very much for listening. And if you've been able to follow with this fast pace, then a huge congratulations to you. I'm going to stop it there. And Coetzee, I'm going to hand over to you to facilitate a discussion.
Thank you so much, Ronelle, for the informative and very interesting session. What I also appreciated more was the fact that you were able to guide us on where to go in case we get stuck. So thank you for also explaining to us on how we can use ChatGPT. Okay, so I'm going to ask participants to kindly fill in the evaluation form. I have pasted it in chat, so please do fill it in as soon as you can. And then I think at this point, we do not have any questions in chat, Ronelle, but maybe we can open up to participants in case they have any questions that they would like to ask. Okay, so if anyone can raise your hands if you have any questions or any point of clarity. Okay. So in chat, a lot of the participants were they were saying that yeah, the session was quite informative and they were appreciating your presentation. Okay, Elodie, you have your hand up. Please go ahead.
Okay, thank you for this presentation. I want to ask if we want to have more training in SPSS. What is the possibility to have this? Thank you.
Thank you, Elodie. It's good to receive such valuable feedback. And yeah, once you've kind of hit the surface, then it's like, yeah, you want to have more training. I won't be able to answer that officially, but you can also write to the organizing committee, and if your organization would like to train a large number of people at your organization, maybe we can make that possible to facilitate something virtually where we have maybe a whole day or even a whole 2-3 day training where we really get into hands-on and we go much more slower so that everybody is following and at the same pace. So we can definitely do that, and there is always opportunities to do that. So you can write to the organizers and put that forward. And Sarah is here, she's part of the organizing committee and other HSRC members. So if they, it's also a lesson for us for next time that maybe we can make this into something longer, or there is opportunities to extend this in the future. So thank you for the interest.
Thank you, Ronelle. Do we have any more questions?
I'm seeing, yeah, this needs hands-on all the time, continuous training. Yeah, it's difficult to, attend a 2-hour session And then you're like, well, when do I ever use this? And then you close your laptop because it's 4 o'clock and you go off and enjoy the day. And, you know, it's true with these things, you have to use the software all the time. And that's sometimes just, you have to have the initiative to go back and teach yourself and play the recording and go through the examples, because that's the only way to stay informed and keep hands-on all the time. And if you're going to actually be using some of this in your PhD or in your work or whatever it is, then that in itself will give you an opportunity to use the software all the time. Sarah, go ahead.
Thanks, Ronald. This was really great. I wanted to know from your opinion and perspective, having used other softwares, statistical softwares, what would you say are the kind of advantages, disadvantages of using SPSS? Would you recommend it? Would you recommend it to more beginners, to quantitative analysis, anything like that?
Thank you, Sarah. That's actually a good question. We didn't get to cover that. But SPSS is actually preferred by so many social scientists. Like I've met professors that are, you know, in their 60s and 70s at like major universities overseas, here as well. And they're like, they swear by SPSS. They're like, what are you using Stata? What are you using R for? Let's do SPSS. And SPSS is just, it's so, it's preferred because it's so hands-on and it's so intuitive and it's so like the human mind. You don't have to go and write long streams of code and then decipher code. You can just actually click and say, what do I want to do? I want to analyze, and then I want to recode into a different variable, and I want to do that. And if I want to get more advanced, then I can save that in a syntax file, and I can always send that syntax file to a statistician. He can replicate or follow my logic and my thinking of what I want to do. But it is preferred mostly because it's just so hands-on and it's so, you know, it's easy to follow that this is what we click and this is what we want to do. And even the output window is actually like, I use Stata, I use R, I've used SAS before. And I can actually say that the output, the quality of the output that you get from SPSS is actually so easy to present to another audience and so easy to put into Excel and put into presentations. So that's why it's preferred. And it's actually the choice of software. It first started off as a software for social scientists. I think that's even what SPSS might stand for. So it's actually the preferred one for social scientists. Yeah. Okay, is there any other questions that we didn't cover that I know there were a lot of questions earlier in the chat that I didn't see. I'm sorry our polls didn't work as we intended, but I think we got there. And then a reminder that this recording is available and you can go and view it and play it afterwards. So is there a PowerPoint in SPSS? No, but there are a lot of online resources. And if you go to the IBM, it's IBM SPSS, there's quite a lot of manuals. There's even if you type into Google, how do I do this on the source, find me some learning software. There's so many tutorials on YouTube and so many, there's not always one user manual, but there are even books. If your university has books, the main book from SPSS is Andy Field, and that's been written and rewritten for the last 4 decades. And it's very concise and it's actually like a proper manual. It shows you step by step what to do and how. So if you can get hold of that from university, that's amazing. But yeah, otherwise there might even be certain modules that are published online from that. So go and search for that.
Hi, Ronald. A few seconds to go. A quick question from Pumza. They're asking whether you prefer SPSS or R. So Pumza is in biology, and they were taught SPSS in undergrad, but noticed that people in their field use R. So so between SPSS and R, what would you prefer?
It also depends on what you want to do. So a lot of people working with biological data, yeah, they do prefer R because you can, if they want to modify and make their own algorithm or their own program, or even say, I want you to do this, but for every observation, I want to program a loop so that you do it repeatedly. And then you bring in some other logic in between that. You can do all of that in R. You can't quite do that in SPSS. So when you've got these complex biological data sets and you want to say if this, then that, but also that and that, it can be a little bit, it takes more effort to do in SPSS, and it's easier to do that in R. So in that instance, yes, R, but again, depends on the analysis you want to do. So I have been talking for 2 hours, and I'm going to go have some coffee now. But thank you very much for listening, and thank you so much, Kwesi, for doing such a great job with facilitating. Thank you for attending.
Thank you, Ronelle, and thank you everyone for participating and for attending the session. Thank you so much. Goodbye.
Thank you, colleagues. Thank you. See you tomorrow for Atlas TI.
Bye.
Bye. Recording stopped.
Thabo,
I'm still here, Sarah.
I just wanted to see if you had a minute for us to look at that report, attendance report.
Yeah, the one that I've sent you.
Yeah, I emailed back to you one, and I thought maybe you could have a look at it and see what you thought of it. But my numbers are not adding up.
Let's see. Okay,
But what do you think of at least the structure?
let's see. Perfect. This is clean. Raw waiting room was excluded. Okay. Admitted. No, this is cool. But then let's see. Module detail. Okay, session participant. Wow. No, I think this is clean. Attendance mean. Wow. Yeah, I think this is perfect.
But
I think
why
this
are
is
my
perfect.
numbers not adding up? Because I recorded yesterday 250 for module 6. So where am I going wrong?
Where's the total here? I don't see the total. Let's see. Where are you looking at source of
My total.
duration? Did you
No,
check?
so we wrote it down. We wrote it down manually to keep track. And I had written down. So I'm wondering if we are filtering this report at all.
Remember, we started earlier. We always start earlier. Yeah, I don't know. What do you have? What do you have in writing?
I have 250s. I have 266.
266. 266. You know what? I will. Is that the duration or the number of the participants?
Attended, it's number.
It's number, eh?
Yeah, I'm wondering is there another attendance report, or are we filtering out something maybe?
No, I just downloaded it. I didn't filter anything. Let me go back. Let me see if I can get something there. You know what? I'm going to. Can I phone you on Teams? Then I share my screen.
Yeah, let's do that. Okay,
Sure.
perfect. Thank you, Thabo.
Sure. You're welcome.
Goodbye.